Morning grade 12. You're speaking to Kosa Tandi. I am going to be doing trigonometric with you today. This is a very nice, simple and focused topic. It will be part of your paper 2 in final examination. The reason we selected this trigonometric is because it has more marks than other topics in paper 2, or compare with the other topics in paper 2, and this one can grant you the pass, at least which the national department want you to pass with. So let's look at the questions that most of you are struggling with answering and see how we can try to grab marks out of it. Okay, this question normally starts from question 5, question 6 and question 7. So we'll deal with them playing around them with from different previous question papers. Question 5, the first one that we have selected, is in this format. So let's start with question 5. It is previous question papers, question 5. Okay, the instruction that was given to us was in the diagram. So there is a diagram there. Let us draw the small diagram we're talking about. So this is the question paper we are looking at. And now let's draw the small diagram they're talking about. In the diagram, which is a Cartesian plane, there is a point P, which is there, with coordinates K and 1. Okay, and there's a theta there, which is going in there. The radius is the square root of 5, and there's a point there they've written being R. And let's read the statement. They said, in the diagram P, there's P, K, and 1 is a point in the second quadrant. So this is our second quadrant. And we have a radius with the square root of 5. From the origin, this is line OP. And they're given us the positive x-axis of the obtuse angle theta. So you can see ROP. So this is ROP. This is the angle. It is theta. Now the question number 1, 5.1.1 says, calculate the value of K. So looking at K actually represents the x-axis point. So it means we're going to try and construct a right-angled triangle. Remember, folks, the moment you have to deal with a right-angled triangle, you can use Pythagoras theorem, you can use the ratios of trigonometry, which is the definition. Now, with this one, because we can quickly label them in this way, K represent X, so we can put it here, and 1 represent Y, which we can put there. Now, in this one, when they say to you calculate the value of K, you can see you have R, you have Y, you are looking for X. So we can use Pythagoras theorem. So let's answer that one. It's 5.1.1. And it means we are going to say, okay, R squared equals Y squared plus X squared. This is our theorem of Pythagoras. Okay. Pythagoras theorem says the longest side squared equals to the sum of the adjacent side squared as well. So our R is the square root of 5. So we're going to say square root of 5 squared. And our Y is 1. We are looking for X, which is K. Okay, we can substitute that to be K so that we remember what we are looking for. And simplify, the square root of 5 squared will give us a 5. And 1 squared will be 1 plus K squared. If we do the algebra there, we'll have 4 equals K squared. And therefore, K is equals to plus minus the square root of 4, which makes K plus minus 2. Now, look at the Cartesian plane. It's on the second quadrant, whereby X is negative. So we are going to choose the one for negative, meaning that K will be equals to a negative 2. So we can say this is now a negative 2. Okay, we have found the solution for the first question with just the simple Pythagoras theorem. Now, this statement comes and say, and they bold this statement usually, they say, without using a calculator, calculate the values of, and they start listing them all. You must bear in mind that calculator is not used there. That is your instruction. Okay, that is 5.2.1. And in 5.2, that was 5.1.1, this is 5.1.2. There's number A there. Number A, they want us to calculate what? Tan theta. Now, tan theta, we can find it by saying it is opposite over adjacent. So it is opposite over adjacent. It's going to be y over x. So it means it's 1 divided by -2, which gives us a -1 over 2. That is how we find our tan theta. Number B says we must calculate the value of cos 180 plus theta. Now, folks, remember 180 plus is on the third quadrant. It's here. So 180 plus theta was supposed to be there. So it means we're going to simplify this first by putting a negative cos theta. Remember to keep that negative with you and look for cos theta, because that's what we are talking about now. But the 180 plus theta, it has been represented by the negative. Now cos theta there will be now adjacent over hypotenuse, which is x over r. So it's going to be a -2 divided by the square root of 5. There's a negative outside the bracket. Multiplying them will give us a positive, so that is 2 divided by the square root of 5. There's 2 marks. 1 mark will be for the simplification, and the other mark will be for the location of the solution. Okay, and the third one, it says, now they are actually trying to confuse you. Do not focus on the confusion, focus on the information that you know, logic, and that's what we need. They said to you, this is 5, it is number C, still on 5.1.2. They said sine theta plus 60, and the question was, oh, you need to calculate without using the calculator the value of sine theta plus 60. Now if you look at it, there's nothing that you can do really in terms of that until before you expand this one. You must expand it. How do we expand? Quickly run to your formula sheet. This is your formula sheet. Remember, the formula sheet will be there for you. Run to it and look at something that looks like this one. There we have the compound formula, sine alpha plus beta, and they expanded it. So you're going to expand it like that, looking at the formula sheet. So this is going to be sine theta cos 60 plus sine 60 cos theta. That is your expansion. You need to bear in mind that the expansion for sine, it does not change the sign, but it changes the ratios, and that's what it does. Now you can deal with this one, because sine theta, therefore, you have it there. Sine theta, it is opposite over hypotenuse. So it's going to be 1 divided by root 5. What is cos 60? Cos 60 from the special angles is 1 divided by 2. And what is sine 60 from the special angles is root 3 over 2. While cos theta, we know that it is going to be -2 over root 5. So there it's -2 divided by root of 5. So this is what we are having at this moment, because cos theta, we just found it, cos theta is adjacent over hypotenuse. Okay, folks, let's multiply this out. We'll have 1 divided by 2 times the square root of 5 plus, so we're going to say negative times positive, give us a -2 times the root 3 divided by 2 times the root 5. Now, having them like this, it simply means that you need to look at the lowest common factor. Lowest common denominator there is 2 root 5, 2 root 5. Folks, 2 root 5 can be written as the square root of 20. So you can put the square root of 20, which now had satisfied the form that they wanted you to do. Because they said, write this in the form of a plus b divided by the square root of 20. Can you see that? You must simplify this one such that it accommodates this one. You calculate this one to be in this form, not exactly with a and b, but the form. So the denominator, therefore, it has been covered already by doing this. Okay, then you add the numerator. This will be 1 minus 2 root 3. And in that way, you have your a and your b and your root 20. Then they give you 5 marks just by doing this one. Folks, this is one of the questions that is unexpected, and most of the time you won't be taught this kind of questions. You use logic to get it right.
Sound rolling, camera rolling.
Okay, matrix, let's now continue with this trigonometric. A very nice, straightforward and simple questions. This is the questions that is coming at the first question that is given as trigonometric. Sometimes it's question 5 and sometimes it's question 6, depending on the question paper. Now, look at this question. The first one that we have done, the diagram was drawn for us and was straightforward. Now the diagram is not there. What are they saying now? They say, if you are given cos of 2 theta being equals to negative 5 over 6. So it's still on question 5. So let's write that question down. We are still in question 5. Okay. And the information, therefore, it says, if cos 2 theta is equal to negative 5 over 6, and it's not ending there. They said where 2 theta, it is in a boundary of, or is an element of 180 degrees and 270. So you need to remember where that is. 180 to 270, it is on the third quadrant. Because when we draw a Cartesian plane, we read 0 to 90 to 180 to 270 and complete it at 360. So that's where your 180 is, and that is where your 270 is. So whatever you're talking about, it is between this third quadrant. Okay. Now they said calculate without the use of a calculator. So we're not using a calculator again, but we have to find the value of something else. So when you see these kind of questions, just before you do anything, you must represent this information in your diagram, always. So this is the diagram on a Cartesian plane. What are they saying? Whatever it is going to be on the third quadrant. My diagram is going to be a right angle, the triangle there. Okay, where is the angle 2 theta? The angle 2 theta we are talking about is the one that is there. So this is where 2 theta is, this angle there. Okay, now we're given that it's going to be equals to a negative 5 divided by a 6. Now, go back to our basics. Remember that if you had a Cartesian plane with a right angled triangle with r, x, and y, where this is theta, your cos of theta will be adjacent over hypotenuse, meaning it's x over r. That means that negative 5 represent your x, while 6 represent your r. So that's what you're going to do on the sketch. You must label them as such. Look at this. Your negative 5, it's going to be in the x-axis because represent x. And your 6 is going to be the r, which is your hypotenuse. What are you looking for now? It is your y. Your y is now missing. You need to find the y. And before you can even look at the question, by representing that is telling you that y is missing. Immediately so, use Pythagoras theorem and then find the missing side. So let's do that. If we use Pythagoras theorem, we'll have, remember it's r squared equals x squared plus y squared. So our r is 6 and our x is negative 5. This is equals, and we are looking for y. And this is going to be 36. That's 25 plus y squared. So 36 minus 25 will give us how much? So this is 36 minus 25 equals y squared. Y will be equal to the square root of, remember it's y, so it should be plus or minus. The only thing that comes positive, it is always r, because r is a radius. Radius cannot be negative. So with y and x can be negative depending on the side where you find it. In the third quadrant, both x and y must be negative. So you can quickly run to your calculator and then make sure that you get it right. So here we go. We're having the square root of 36 minus 25 and gives us the square root of 11. Now you go to the Cartesian plane and check. In that means y is going to be equal to negative the square root of 11 because we're on the negative side of the y. So there your y, therefore it's negative the square root of 11. We haven't yet looked at the question, but we have done this all, and it consists of marks as well. By showing this, you have some of the marks already before answering the question. The question number 5.1.5.1.1, so it's 5.1.1, says that we have to calculate without using the calculator the value of, in the simplest form, of sine 2 theta. So that's what you're going to write. What is sine 2 theta? Remember our angle is 2 theta. So sine 2 theta, it is opposite over hypotenuse. So it's going to be a negative the square root of 11 divided by 6. And this one is 4 marks. Folks, the 3 marks will have run through this 2 that you have started with, and then the other marks will come to that part. Okay, 5.1.2. So let's go to 5.1.2. They said you must find what? Sine squared of theta. Sine squared theta. Folks, bear in mind that your diagram does not have theta, and you cannot create theta in the diagram. So you must do something to get to that theta. How do you do it? Your formula sheet is a key. Go to the formula sheet, check what is it that can relate to the sine squared of theta in terms of 2 theta. So somehow you'll have to change it and put it where it's supposed. So your formula sheet here and information is very important. So let's look at it. If I look at sine squared theta, I can try to change it using anything. For now, I can go to the formula sheet and check cos 2 theta. Remember, it has 3 things. So it can be cos squared theta minus sine squared theta, or it can be 1 minus 2 sine squared theta. So if I use 1 minus 2 sine squared theta, have you guys realized that already I have what I'm looking for? Sine squared theta. What I need to do is just to make it the subject of the formula and get to the solution. What is cos 2 theta? Cos 2 theta was given to me as negative 5 over 6 there at the first statement. So that's what I'm going to do. This one I'm going to substitute it by negative 5 over 6, and I have 1 minus 2 sine squared theta. Remember, we are looking for sine squared theta. So this is our key where we want to go to. Okay, so we'll have to work it out, play it around until we have sine squared theta equals to something. So this is, let's take out the 1 to the other side. So it's minus 5 over 6 minus 1 equals minus 2 sine squared theta. We still don't need the minus 2, so it means we have to take it to the other side as well. So we are going to divide both sides by that minus 2. So if I divide that by minus 2 and divide the whole thing by minus 2, the minus 2 will cancel with the minus 2. Then I remain with sine squared theta. With you guys, you can go in and then use a calculator. Then you'll get what sine squared theta it's equals to in terms of that. Punch it as it is on the calculator. Just use your fraction buttons twice, and it will give you what you are looking for. So it's, let me quickly do it on the calculator so that we don't waste time. Remember, calculate is one of the things that saves time. So it's giving me 11 divided by 12. So that means that sine squared theta is equals to 11 divided by 12. They just tricked you, knowing that you'll end up taking this and use 2 theta and forget that you are dealing with theta. So you must first change it to this, which is part of your information sheet, and then come to the solution as it is. So this is the answer. Sine squared theta is equals to that. So with 5.1, we are kind of done with it. So this was 5.1. Let's go to 5.2. And now 5.2 is out of what we're doing. 5.2 is something else. Let's look at the question. Folks, this one needs focus, concentration, and some of the information that you have to revise. Now, this is what makes trigonometric looks difficult or complicated. It's because most of the information you must try to bring it on by the time you are writing. So you must try to practice it as much as you can so that this information stick to your head. Okay, now let's write the question down. In this one, they say simplify. Now, simplify simply means do something until you can't do anything. You must simplify this to a single trigonometric ratio. Whatever you do, at the end, you have to have one single trigonometric ratio. Folks, single trigonometric ratio means you have to end up your answer with either tan of something, cos of something, or sine of something. Not 1 plus, 1 minus cos, 1 minus tan. It has to be one term. So it's either it has been divided becoming one term or something like that, but you cannot have 2 terms. That is the meaning of one trigonometric ratios. Okay, let's write the question down. They said is sine, it is sine 180 minus x, and it's multiplied by cos of negative x, and it's added to cos 90 plus x. And we're going to take it a little bit down to continue, but then it's multiplication. It's multiplied by cos x minus 180. Remember, this is on the same line. Okay, having it like that, we must simplify and make sure that we get one trigonometric ratio. So let's start. In here, if we look at it, we are not doing something that we don't remember, because when you reduce in grade 11, we're using this Cartesian plane with 180 plus or minus 360 plus or minus. So we are doing that here. We're going to say 180 minus x. Where in the Cartesian plane I'm going to find 180 minus x? It is on the second quadrant. Is it sign positive or negative? My sign is positive, so that is going to be just sine x. And you multiply it by cos. Remember, folks, negative angle is in the fourth quadrant, and in the fourth quadrant, cos is positive. That Cartesian plane, some people call it cast, some people call it many other things. So maybe we can try to draw it here and remind ourselves about it. This is cast. And my student says, all silly teachers complain, and some says, all student to copy, and some student, one of my students say, allow student to copy, especially in maths, because they are failing it. So if we allow them to copy, they can get it right. So this is the slogans you can try to use and remember what you are saying. Whatever works for you, you can use it. So when I say sign is positive, I'm talking about where is in the second quadrant. This is the quadrant I'm talking about. So that is why we ended up with the sign x. Remember, we say this is where 0 is, this is where 90 is, and that is 180, and that's 270. Then we end up with 360. Okay, so the minus is here. 180 minus is on the second quadrant. Now, the fourth quadrant has the negative x. That is why we are saying the cos will simply be a positive cos of x. Okay, folks? Let's go to the third one. Okay, they said plus. Cos 90 plus x. Now, cos 90 plus x, it has a partner. The moment it is starting talking about 90 and 270, it's married. Now it's talking with the other partner, which is now sine. If it's just cos, remember cos, if we call it fully, it's cosine. So if it's sine, it means its partner is going to be cos. If it's cos, it means they are together. Now it's cosine. They're now married. Now you have that cosine. You need to take the wife and leave the husband, the cos. You use the sine. So it means that we are going to use sine. However, while using the sine, we have to look at the fact that where do we find cos and where do we find 90 plus? Remember, 90 plus is on the second quadrant. And on the second quadrant, only sine is positive. Cos is going to be negative. That makes our sign here to be a negative sign. So you need to be careful of this thing. You need to take note of it because it's very important and it can make you lose marks. And now look at the last one. That is cos x minus 180. We are used to 180 plus 180 minus. But we can break that because it's just what we are used to. We can still make something out of it. Let's see. If I have x minus 180 and then I rearrange it, I'll have negative 180 plus x. If I take out the common factor, I'll have negative 180 minus x. Can you see if I multiply this, I'll go back to what I have. So it means what we are going to do with this is actually this part. Okay, so we're going to put our cos, put a negative, and also the angle 180 minus x. Remember, folks, negative is in fourth quadrant. Then that means cos is going to be positive. So that is your first statement. You'll have cos of 180 minus x. You can write it within the statement, but sometimes there's no need for you to. You can do it aside. Then having it like this, we go to the second quadrant where cos is negative. So this has become negative cos x. Do not confuse this information. It's very important for you to be alerted about it. So we are going to multiply this with a negative cos of x. And that is our first part of simplification. Then we start multiplying out the negative. This is sine x times cos x. The negative times a negative will give me a positive. So we remain with positive sine x times cos x. Now, if you look at it, we have cos x, sine x, sine x. It's like we are having x and x, if you look at it like that. So we can add them together, for which we'll have 2 sine x cos x. Now, 2 sine x cos x is written in your formula sheet to say this is the double angle of a sine. So you can write it as sine of 2x. Can you see now you have your single trigonometric ratio, and then that's where you'll get your full marks in total. Okay, let's see if there's another question for this one. I guess that was the last question for this, and it was 6 marks. Look at it. It's just as small as it's just that this information must be inside your head for you to be able to get this full 6 marks. Okay, thank you, folks. Okay, matrix, we still continue with the revision of trigonometry, and a similar question has been selected as well. But now this one is a diagram with a Cartesian plane with 2 lines from the origin, and some other information is given to you. So it's still in question 5. So let's write the question. It's question number 5, and it is given as such. 5.1, they're saying P, it is minus the square root of 7 and 3, and S is A and B are points on a Cartesian plane. As shown in the diagram below, P angle OR is equals to P angle OS, and they are all equals to theta, and OS is equals to 6. So let's try to draw this diagram, and then we can start working on what they want. I'm going to draw it along the side. It is in this manner. That's where your P is, which is minus the square root of 7 and 3. This is where your other point is, which is S with A and B. Remember, we're given that this is 6, and then the angle that is moving from there to there is theta, while we are told that also the angle between there to there is another theta. Okay, they say they are equal, so that's what we are having, and there's a point R given to us. Okay, let's see. Now, when it's like this, it has been given to you. What is important now, it is the instruction. What are they saying? Determine without using a calculator. So whatever you do, a calculator is not part of the solution here. You have to do something to get to the solution. Now, remember, folks, we said if you are given something on the Cartesian plane, you must create your right angled triangle. That is your first step. So our right angled triangle, our first one will be the one that we construct from P perpendicular to x-axis, and try to locate the information given to us. Look at it. The negative square root of 7 is our x there, so we can put it there, and 3, it is our y there. What are we looking for? Our r. So r is not there. We need to find r. In this case, to find r, we use Pythagoras theorem, and that is always the case. Now the other one, it is this line there. We can construct it and make it perpendicular to the x-axis. The A is going to be on the x, and the B is going to be on the y. So those are our 2 diagrams that are given to us. They are not intersecting in any way because they are not equal in size. And that is the important part of it. Don't make them equal because they are not. It's not up to scale, but you must make sure that they are not equal, and try to put every information. Immediately before you look at the question, try to find the missing side if you can. And now that missing side can be found if 2 side is given in Pythagoras theorem. Okay, let's find the one for here. It's r squared equals x squared plus y squared. Our x is negative the square root of 7, so we square that, plus 3 squared. That is our r squared. Okay, but our r will be the square root of, then we put a negative 7 squared will give us a 7, and then a 3 squared will give us a 9. So we add them together, will give us 16. And that means that r will be equals to 4, because the square root of 16 is the same as 4. So it means that you are missing thing there. It's now 4. Okay, now for that matter, it means now you can move away and start looking at the question. Now the trick is you must allocate all the information given to in a diagram before you can start looking at the question, so that don't get confused, right? Then after here you go to the question. 5.1 says find tan theta. It's going to be simple because now we have everything needed. So that is our 5.1.1. We must find tan theta. So tan theta, therefore, it's going to be, because remember tan is opposite over adjacent using a SOHCAHTOA slogan. So it's going to be tan theta, it is opposite over adjacent. Remember the adjacent we're talking about here is for the negative, the square root of 7, not the a. So we're going to say negative 3 divided by the square root of 7. And now that is your tan theta. Then they give you 1 mark. Can you see how simple that can be? It's not that bad for you to get that mark. It's very simple. And don't worry, this one will get marked somewhere on the road. Just that they had these 2. That is why they did not give it marks for it. Okay, remember tan theta associated with x and y. That is why they didn't give you a mark. So because it's y divided by x. That is why it's like that. If you look at it, you're taking it from the statement. It's not coming from the workout. This workout will have a mark with another question. So let's go to question 5.1.2. In 5.1.2, they say, find sign of negative theta. Interesting, and they just want you to be stuck because you will be confused just by seeing a negative theta. Folks, this is trig. All the things that you have in the trigonometric are working together, are online. Remember, the negative angle on the Cartesian plane is in the 4th quadrant. So where sine is negative. So it means you're going to write this as having a negative sine theta. And then you look for sine theta to find a solution. What is sine theta then? Sine theta is opposite over hypotenuse. Now if you look at this one, it has 3 marks. Can you see that some marks will be coming for this one? Because by doing that can give you 3 marks. So it's going to be opposite over hypotenuse, meaning that it's going to be negative 3 divided by 4. Now this is where you get your marks. One will be saying, can I get 3 marks just by doing this? No. Other mark is coming for you who have been doing this, because now you are using the 4, and now the 4 is working there for which you have worked it out before. They will go to that part where you have write it, and they will give mark for it. You don't have to stress and say, I need to put it in line with the question. Because it's there on the same question, they will award a mark for it. You shouldn't be stressed. Okay, number 5.1.3. If you look at this question, I guess most of the learners wouldn't answer it. Because, okay, let's write it a little bit there. It's 5.1.3. Okay, 5.1.3, most of learners would leave it, but it has 4 marks. And I will understand why, because a little bit confusing because of the question which is structured. But let's look at it and remember the instruction, because if you forget it, you'll do something and you'll make it wrong. They said determine without using the calculator the value of A. Now, if you are looking for the value of A there, it means now you are in this Cartesian plane. And if you are in this Cartesian plane, you are looking for A. One of the things that you know you don't know is this angle that you are dealing with. You know it as a theta from this point. So what is it that you are going to do? You have A, B, and C as a side. It means that you are going to use your Pythagoras theorem in this triangle. So this is going to be, remember, this is r squared equals x squared plus y squared. And what is your value of r? Your value of r is 6. So you square it. Your value of x is what you are looking for, is A, and your value of y is B. You don't know what that is, but you have been given letters. So you write them as it is, because that's what the question wanted to do. And after that, you have to remain this side with A. So taking the b's by subtracting, that is 36 minus b squared is equals to a squared. Now you are looking for a, remember, so you have to put the square root both sides. So a will be equals to plus or minus the square root of 36 minus b squared. And one can factorize it further, you can leave it like that, but then your value of a will be associated with this. Only if the value of b was given to you, you will therefore have the actual value without anything. But because you don't know b, this is how far you can go in answering the question. Okay, folks, I get this is a little bit straightforward, and you just don't be tempted. You must make sure that you do it as it appears, and look at the relevant question that is given to you. Okay, with this Cartesian plane given to you, that question is done. So let's go to 5.2. Okay, in 5.2, they are giving us some interesting information. It is very interesting to do this thing. Okay, let's look at it. It is interesting because you have to now little bit look at your formula sheet and try to use whatever it is that you know. So this is the question now. In the question they said simplify. Now the moment they say simplify, you need to know that you need to do something beyond what you have. It's not just the formula sheet. The factorization comes in. The substitutions of other things comes in. So what is it that we are simplifying? The expression for sine x cos x all divided by 2 sine x minus 1. And you have to simplify it to a single trigonometric ratio. If I was you, immediately when I see it like this without numbers, I will run to my formula sheet, put it in front of me, and then look at the relationship. First of all, there is something that has sine and cos in the formula sheet, but it's not 4 here. What is it? It is 2. So it means you're going to say this is the same as 2 multiplied by 2 sine x cos x. Going to the formula sheet again, you can see that there is something that can look like this one. But if you look at it in that manner, it says 2 sine squared x minus 1. 2 sine squared x minus 1, you'll have to rearrange it a little bit first. Let's see if we rearrange what we are going to have. A minus 1 plus 2 sine squared x. Now, if I have this, I'll have 2 times sine 2x, because 2 sine x cos x is the same as sine 2x. So that is coming from the formula sheet, direct. But in the denominator then, I need to work out what is coming out. There I need to take out the common factor of a negative. Then I left with 1 minus 2 sine squared x. Folks, I'm doing this so that it will accommodate what is on my formula sheet, because 1 minus 2 sine squared x is the same as cos 2x. So it means I can change now this to cos 2x. I'll have a negative 2 sine 2x divided by cos 2x. Can you see I'm leading to what I want? Because according to the identities, sine of an angle divided by cos of any angle is the same as tan of that angle. So it means that sine 2 theta divided by cos 2 theta will be the same as a tan 2 theta. 2x. So you can see now I'm on my one ratio. I'm on my single ratio. It's just tan to x. So you need to be careful of those things and try to relate it based on your formula sheet. So this is the same as that. Change them and get your marks. Very straightforward, and you're just using the formula sheet to get them right. 3 marks, because you're not doing much. You're actually going to the formula sheet. That's why it's not that much. But it is the marks that you can grab and then make sure that you don't miss them for unnecessary reasons. Because the formula sheet is there. You just go into it and play around it. You get to the solution. Now, there's another question they said. Hence. Normally when they say hence, most of us will leave it out. Hence simply means use what you have done to do what is coming up. And now they give you something, but if you look at it, you'll see that it's similarly there, just that they change at least an angle and they put a number. That's what they do. So let's see what they are saying hence to. Hence calculate the value of. So that is 5.2.2. We are calculating the value of 4 sine 15 cos 15 divided by 2 sine squared 15 minus 1. Folks, look at this. This statement is the same as this statement, just that now x is 15. There's nothing different. Now, what you're going to do is you're not stressing. You're just going to go straight to the solution. That's what you do. You go straight to the solution, and you're going to say this is equals to a negative 2 tan of 2 multiplied by 15. Because what does this mean is that your x has changed to become 15. And that is the meaning of hence. Take that, use that to get the solution. Then that means you have a negative 2 tan of 30. Folks, we have a special angles. If you quickly run to your special angles for 30, This is your special angle. It's a right angle triangle. So if this is 30, this is going to be 60. Remember, the sum of the angles in the triangle is 180. So then 30 will have 1 there and the square root of 3. Now, what is tan of 30? It is opposite over adjacent. So tan 30 there is going to be opposite of adjacent, meaning it's a 1 over the root 2. So you multiply that with 1 over the root 3. And that is negative 2 divided by root 3. Some of you will want to rationalize, and it's just going to be negative 2 the square root of 3 divided by 3. Either way, this is going to be the correct answer. So that's how we go. So you can write it like that, or you can rationalize to get to this one. And you have answered the question, and voila, you have your 2 marks for the hands instead of leaving it out. Okay, folks, that is the last question of question 5. And then thank you. I guess this will help you. Okay, grade 12, we are continuing with trigonometric revision. And now we are looking at another question, which normally we had challenges when we come to it. But I think we will solve that now as we are doing this one. Okay, looking at this question, it just said straightforward. Still question 4. Question 5, as we said that these questions are usually in question 5. So it's still question 5, and they're saying if x is equals to 3 sine theta and y is equals to 3 cos theta, determine the value of x squared plus y squared. So what are you going to do? You're going to write, it is 5.1, so you're going to write x squared plus y squared is equals to. What did they say x is? They said it's 3 cos theta. Remember, this is square, so you must square it. And they said y is 3, x is 3 sine theta, not cos, so this is 3 sine theta. Okay, and we are adding 3 cos theta from the given information, and we square it. Now, we need to work that out until we reach where they want us to be. So you simplify until you cannot do anything, only on the right-hand side. So let's look at this. Remember that 3 squared is giving us 9. So this is going to be 9 sine squared theta. And the 3 cos theta will give us a 9 cos squared theta. If we take out the common factor of a 9, we will have 9 multiplied by sine squared theta plus cos squared theta. This is one of the identity that says sine squared theta plus cos squared theta is equals to 1. So that's always the case. So it means we're going to change this to make it 1. So this is 9 multiplied by 1, which should be 9. Meaning that x squared plus y squared is equals to 9. And they give you your 3 marks. Can you see how direct that is? It's not difficult, straightforward. Everyone can write it in this manner. Okay, let's go to 5.2. Angle multiplied by sine of negative x minus cos of 180 degrees minus x, and multiply by sine of 90 degrees plus x. Folks, looking at this question, you can see the variety of many things. It is 6 marks. To start with, there's 540, meaning that the revolution has been completed, and then we go to the third quadrant, and then we go again to the first quadrant and to the second quadrant again, but after the revolution. So it's 360 plus. Now, what are you going to do here to split this thing to have 360 plus something to give you that particular 540? And bear in mind that you have to simplify to a single ratio. So let's do this. To get 540, I guess we can say 360 plus 180 will get 540. You can quickly check that as well, that when we say 360 plus 180, we'll get 540. Let's double check. Yes, we are getting it. So what are we going to do here? We are going to split in that way. So we have sine of 360 degrees plus 180, which gives us 540 minus x. So we didn't change anything. Actually, we are using this different bracket, so you can see that there's nothing that has changed. Now, your angle is 180 minus x in this case, so it's 380 plus. Do you understand? It is in the first quadrant. Now, the second one is a negative. Negative is in fourth quadrant. It means that sine is negative there, we have to take the negative out. So we are multiplying this with a negative sine x minus 180 degrees minus is on the second quadrant, where only sine is positive and cos is negative. So we're going to have it as a negative cos x. Now, we are coming to a co-ratio. Remember we said cos and sine, they are married. You see a wife sine, it means you have to introduce the cos, which is the husband. Now we have sine, it means there, its co-ratio is going to be what? Cos. So we're multiplying it with cos of x. But bear in mind that we are in which quadrant? A second quadrant. Our ratio sign is positive. Therefore, this is going to be positive as well. So we are in this same right part. Mind you, if this was cos, it means this was supposed to be a negative sign. So that's how we look at it. So this is fine for now. We need to double reduce this one. 360 plus is on the first quadrant where everything is positive. So we're going to write it as 180 minus x multiplied by a negative sine x. Use a bracket so that you don't confuse your signs. Instead of using multiplication, you therefore start using a negative to change the statement. So this negative and the negative will multiply, and that will be automatically be positive. And there you'll have cos of x multiplied by cos of x. Now let's go back to this part. We still have 180 minus. 180 minus is on the second quadrant where sign is positive. So we're going to put our sine x multiplied by the sine x. Remember there's a negative, so we're going to put our negative there so that we can remember. And this plus cos x times cos x. If you look at it, this is sine x, we can make it sine squared x. This we can make it cos squared x. So let's do that. This is negative sine squared x plus cos squared x. If we rearrange this system, we take the cos to the first part, we'll have cos squared x minus sine squared x. See something like this, you can relate. This is in your formula sheet. If you run to it, you will find it being the double angle of cos. There's three of them. So there's cos squared alpha minus sine squared alpha in this one. So it means this is the same as cos 2x. That is your single ratio. And do you know how much this is? It's 6 marks. So it means you can get free 6 marks directed and very simple. That is the end of question 5. Thank you, grade 12. Okay, matrix, we're still discussing, or we're still on the revision of your matric final examination 2019. It's on trigonometry. Remember, this is paper 2 and it has more marks that you have to collect in this format. So we're going to start with some questions that are very interesting in trigonometry. These questions are always there with few marks that you all can grab. So let's start with that question. It's question number 6 for this case. This time it's in question 6. So what is it saying? Without using a calculator. Like they like you guys not to use a calculator if you look at it. So you need to stop using a calculator too much, unless if you can use it for which we can see. So you need to make sure that the calculator is not your norm. They say without using a calculator, determine the following in terms of sine 36. Now in terms of means whatever you do, whatever the answer is, but sine 36 must be there. So that is what it means. Not necessarily that the answer must be equal to sine 36, but in terms of sine 36 must be there. So let's see what is the question. And bearing in mind the sine 36 there. Question 6.1.1. We can write this sine 36 in 6.1 so that we can remember. Not that it has marks. We just want to always put it in our mind. They said find sine of 324 degrees. Now, sine 324, it is less than 360. So what you are going to do there is to use 360 minus. So sine of 360 degrees minus whatever angle that you put there must give you 324. So if you say 360 minus 36, you will get 324. And 360 minus is in the fourth quadrant, for which you have to do what? To check if sine is positive or negative. So sine is negative, that means you have a negative sine of 36. And that's what they wanted you to do to that question. The second question, 6.1.2, they say find cos of 72. 6.1.2, you are looking for cos 72 degrees. Now, how can you make cos 72 sine 36? You need to start by, remember you have to do trial and error, then there. In this case, you have to start changing the 72 and see if it can give you 36. I think if we say 36 plus 36, it will give you a 72. Or if we say 2 times 36, you'll get a 32. So you'll have cos of 2 times 36, which gives you a 72. Now you go back to your formula sheet and check. Oh, in the formula sheet, I have something that is double angle. And for cos, it means that I'll have 1 minus 2 sine squared of 36. So this is the same as 1 minus 2 sine squared of 36. And you do have that sine 36 there. So that's what they want you to have as a solution. And that is about 2 marks. Now, for these two, you can see that what you need to remember is the 36. And from there, you can get it right. Okay, folks? Let's go to 6.2. And 6.2, they want you to simplify. Simplify. No, this case, we are proving the identity, meaning that you have to prove that the left-hand side is equal to the right-hand side. So always they are proving, you must remember many things. If you see tan, make sure that you change your tan to sine and cos. So if you leave it as it is, it will create problems. Change your tan to sine and cos, because sine and cos, they're the simplest. You can deal with them. They have many things on the formula sheet, so you can be able to change from one point to another. So let's do that. Our equation is 1, or our identity is 1 minus tan squared of theta divided by 1 plus tan squared of theta. It must be equals to cos squared of theta. So that is your identity. In proving the identity, you must make sure that you take the complicated side, uncomplicate until it can give you another one. Logically, so you can get it right. So let's try to do that. Let's choose our left-hand side. This is equals to 1 minus tan squared of theta divided by 1 plus tan squared of theta. Before we can do anything, I said you see tan, you change it to sine and cos. Remember, the identity for tan is sine divided by cos. So we can say this is 1 minus a sine squared of theta divided by cos squared of theta divided by 1 plus a sine squared of theta divided by cos squared of theta. There's many divisions there, so you have to try and extend the one that is in between, such as this one, so that one can see. Okay, from there we have 1 minus, so I'm going to rewrite this as sine squared theta divided by cos squared theta, and I'll put my division there so that we don't have confusion. Remember, this is 2 terms, so we need to make it 1 term by looking at the lowest common denominator. So it's cos squared theta, and there we'll have our cos squared theta plus sine squared theta. Our identity for cos squared theta plus cos sine squared theta, it says that is equals to 1. So we are going to do this. So this is 1 minus sine squared theta divided by cos squared theta multiplied by cos squared theta divided by 1. Because when we change the division, we flip and then we multiply the right-hand side of the expression. So this is what we have. These two are the same, so they can cancel. We'll remain with 1 minus sine squared of theta. And 1 minus sine squared of theta, according to our identity that says sine squared theta plus cos squared theta is equals to 1. It means that if you try to make cos squared theta the subject of the formula, you will get 1 minus sine squared theta. Therefore, that is cos squared of theta, and that will be your right-hand side. So after you do that, you will tell us that this is what you have proven and is the same as your right-hand side. Left-hand side equals right-hand side. And you just get your 4 marks. Simple and straightforward. Okay, thank you. Okay, matrix, we are doing one question that we have labeled it question 9. And this question is just on simplification. So let's see how we can simplify. Remember, simplification need you to deal with the reduction formulas, and sometimes it needs you to deal with the special angles. So when they say simplify, you know reduction formulas and also special angles. Your grade 11 work, it's used more in the simplification than in proving. So this is question 9, as we named it. This is question 9. In question 9, first question says simplify as far as possible. Remember I said my definition of simplification is that do whatever you can until you cannot do anything. So that's what we are doing when we simplify. And they're saying simplify as far as possible until there's nothing that you can do. The equation for 9.1, or the expression, is written, or it's given to us as sine squared of theta. Now we are dealing with theta, all divided by sine of 180 degrees minus theta, multiplied by cos of 90 degrees plus theta, and plus tan of 45 degrees. So this is actually your statement or your expression that is given. It is 5 marks. So you must do whatever it is that you can to make sure that you get those marks, because each and every step that you take, it has a mark. So let's see what is going to happen there. When we simplify, we're going to look at what is complicated first. So let's start with our denominator, deal with it and see what we can do in the numerator if there's a need. Here we have 180 minus theta, and 180 minus theta is on the second quadrant, for which sine is positive. So we're going to have sine of theta. And we have cos of 90 plus. Remember I said 90, it means that cos and sine, they have to deal with their marriage issues. So it's like cos will become sine and sine will become cos. So that is covered. We have cos, so it's going to be sine. However, we have to look at where do we find the angle. In this case, it's 90 plus. And 90 plus is on the second quadrant. Our ratio cos is negative on the second quadrant. Therefore, our sine is going to be negative. Put a bracket so that you're in the safe sides. Okay, we add this to tan of 45. In your special angle for 45, tan 45, it is equals to 1. So that is just plus 1. Remember that it's always the case. There's nothing that you can say different from that. Remember the special angles are what we have used there to do sine 45. Okay, now let's simplify this as sine squared of theta divided by negative sine squared of theta plus 1. Now look at this. This is sine squared theta plus 1. Folks, you cannot cancel the sine squared because this is 2 terms at the denominator, is not 1. If you want to cancel or to do something, make sure that your 2 terms had became 1. So if I rearrange this denominator, I will have sine squared of theta divided by 1 minus sine squared of theta. If you go to the identity that says cos squared theta plus sine squared theta is equals to 1, make cos the subject of the formula, you will find 1 minus sine theta. So that means this is the same as cos. So we are going to say we are having sine squared theta divided by cos squared theta, which is the identity of tan. So you're going to write this as tan squared of theta. In that case, you have simplified and we give you your 5 marks. Okay, the last question on this, it is 9.2. This one, they're giving you double restriction. Simplify, we do something until we can't do anything, and they say without using a calculator. Make sure the calculator is not used, but then something needs to be done. Okay, let's check that information given to us. Simplify means it's an expression. So this is sine of 104 degrees multiplied by 2 cos squared of an angle 15 minus 1 and divide by tan of 38 degrees multiplied by sine squared of 412 degrees. So you need to simplify. First, you must do the reducing. Reduction formulas are very important. Look at this. What numbers can you put? Remember when we reduce, we use 360 and 180. So can we say 180 minus something and end up with 104? Everything that you do, you must make sure that it takes you to what it is there. So if I say 180, and then I subtract 76 on it, I'll get 104. So this is sine of 180 minus 76 is the same as 104. And this is my double angle for cos from the formula sheet. So your formula sheet is telling you what you need to do here. 2 cos squared 15 minus 1 is a double angle. So we're going to rewrite this as multiplication of cos 2 times 15 degrees. Okay, then we divide this all by tan 38. Remember I said if you see tan, make sure that you do whatever you can to change it to cos and sine. So we can change it directly. This is now just sine of 38 divided by cos of 38. Folks, if the angle that you are dealing with is less than 90, leave it as it is. Do not do anything to it until you find something that can make it cancel, or that will be the solution at the end of it. So for now, we leave it like that. We're just changing that other part. And this one will be sine squared. Remember, 412, it is more than 360. So what you are going to do is you're going to say 360 plus another value that will give you the answer. So it's 460 plus 52. It is 412. So that is 360 plus 52. It gives us 412. So let's go on and see what is done. Okay, sine 180 minus is on the second quadrant. So it means that we'll end up with a positive sine 76. So this is sine of 76 degrees multiplied by cos of 30, because 2 times 15 will give us a 30, and divide this by sine of 38 divided by cos of 38 multiply by sine squared of 52. So that's what we have at the end of the day. Now, folks, let's look at this. Remember, sine squared of 52 or sine 52, we can try to check if it does not give us the same value as when we add with 38. We said they are married, so it means that if I add their angles for 38 and 52, I must get 90. If that's the case, it means I can rewrite this one as cos. So let's do that and see what we are going to get. That is going to be equals to this. Let's deal with the denominator. It is the sine of 38 divided by the cos of 38 multiply by sine. Let's change this once because it is sine squared of 52. So we can write that as sine 52 times sine 52. They are giving us the same value. But we said sine 52 is the same as cos of 38. So let's write that in a cloudly form. We say sine 52, it is the same as cos 38. Visible and somewhere there. Remember, this is the cloud to accommodate this information there. We are saying that sine of 52, it is the wife of cos 38. Because when we add 52 and 38, we'll get 90. So they became co-functions. It means that the sine 52 can now cancel with our cos of 38. And we're left with the sine of 52 times the sine of 38 at the denominator side. We still have the numerator to deal with. What was the numerator? The numerator has sine 76. So let's write the sine 76 as it is. We will deal with the issue when we come to it. Sine 76 and the cos of 30, if we go to the special angle, let's try to draw that special angle triangle. If this is 30, that is 1 over 2, that is root 3. So cos 30 will be adjacent of hypotenuse. So it is the same as the square root of 3 divided by 2. So that's what we are having in that point. Okay, let's continue. Then it means we'll have the square root of 3 divided by 2 multiplied by sine of 76 degrees, all divided by sine of 38 multiplied by cos of 38. Remember we said cos 38 is the same as sine 52. So that is why we are writing it in that manner. Okay. Now, this, if you remember back then, we said we can rewrite this in a different manner. Let's do it inside the cloud so that you can remember. Remember that in the formula sheet, we are having something like double angle for sine. It is 2 sine 2, let's use theta, it's equals to 2 sine theta cos theta. Now, if I have sine theta cos theta, it means I have divided this one, they're both sides by a 2. So it means I'm left with a sine theta cos theta equals half of sine 2 theta. The same applies with this one. It means I'm having half sine of 38. So I'm going to write it like that. Is the square root of 3 divided by 2 sine of 76 divided by 1 over 2 sine 2 times 38. Okay, folks. Now, what is 2 times 38? 2 times 38 is 76. So it means I can change this now to have the square root of 3 divided by 2 and having the sine 76 all divided by a half sine of 76. Okay, now you see that the 76 is like cancelling. The sine 76 are now giving us 1. So we're left with this 2. If I flip and times, I'll end up with the square root of 3. Okay, so if I say the square root of 3 divided by 2 multiplied by 2 over 1, that is the meaning of flip and times. It will give me the square root of 3 because the 2 will cancel, and that will be your solution. Folks, this question has 7 marks. This is the question that you can go in and collect all the marks necessary. Make sure that you do it possibly. Oh no, it's having 8 marks to be exact. So you can see that this question can give you more marks as you deserve. What is important is your core functions information and your double angle information. If you do this, practice and practice and practice, you'll get it right. Okay, thank you. Okay, matrix, we're still continuing with the revision of trigonometric. Remember, you're going to write the final examination and trig is in paper 2. You're going to find it very interesting if you revise it now and there. So like looking at these questions, when we created these questions, there were too many trigonometric questions. So it became question number 12 instead of 5 and 6. And I said to you at the beginning, these questions are usually in 5 and 6. So don't be surprised if you see it being question number 12. Just that there's a bunch of many questions from previous question papers, and this was allocated to number 12. So in this question, this is what was given to us. Let's look at it. It's still on the proofs, so it's written in question number 12 for the pamphlet that we are using. Okay, in question number 12.1, they said, prove that. This can only be proved if the denominator is not equal to 0. So they have explained to that this cos alpha minus x cannot be 0. So let's write the question down. This is 12.1. They said sine of x plus 450 degrees minus alpha divide by cos of alpha minus x equals 1. So we must prove that if the cos of alpha minus x is not equal to 0, then the left-hand side is equal to the right-hand side. In other words, this whole statement will give us 1. So you need to be a little bit creative to do that logic. Let's see. To start with, here we are not used to start with letters. So we need to rearrange this one, take this and put it at the beginning so we can be able to do this logic. Okay, let's see. Let's choose our left-hand side because it's complicated. This is equals to sine of x plus 450 degrees minus alpha. And our denominator, therefore, it is just cos of alpha minus x. Let's play around with the numerator until we can get something that looks like a denominator such that it can cancel. That is the logic behind this. Now, first we have to interchange this so that we can be able to arrange. Let's do that. So it's sine of 450 degrees. Which one do we want to start with? Alpha. Why? So that we accommodate our denominator. So it's minus alpha plus x all divided by cos of alpha minus x. Folks, make sure that your divisions are written and are visible. You don't need a ruler for that. Just put a line to save time, and then the marker can see what you are trying to say. Now let's write it in this manner. This is sine of 450. If we take out the common factor of a negative there, we're left with, so let's use a square bracket for this one. We're left with an alpha minus x. We are going there. Can you see? We have that alpha minus x now. So, but we need to work it out until it gives us what we want. So that is alpha minus x. Okay. Continuing, 450, how do we get it? We need to say 360 plus something. Remember, we don't have an angle that is just 450. We must reduce it from something. So we are going to have sine of two numbers that when we add them together can give us 450. So that one will be 360 plus a 90. If I say 360 plus 90, I will definitely get there 450. But this 90 must have this angle alpha minus x on it. Okay. And we have to divide this by the cos of alpha minus x. Folks, if you look at this properly, you can say that because of plus, I can simply put a bracket there. That will make my angle 90 minus alpha minus x in that particular bracket. So if this was theta, I will say 90 minus theta. But now we have alpha and minus x as our theta. So you substitute that in that manner. So 360 plus is on the first quadrant for which all ratios are positive. So even sine is going to be positive. Therefore, we're going to write it as sine of 90 minus alpha minus x. And we divide that by cos of alpha minus x. Remember I said sine is the wife while cosine is the husband. So in this case, we have a sine and we are in 90. It means that we have to use the husband, which is a cos. But we have to look at which quadrant are we. 90 minus is in the first quadrant. All ratios are positive. So it means this is going to be positive cos, not sine anymore. Because if it's a wife, sine, and then we put a husband cos just because of a 90. There's 90, you always interchange the cos and the sine. So this is going to be cos of alpha minus x, which we divided by the cos of alpha minus x. Voila, we are in the same thing now. Then we can cancel them. This two will give us what? A 1, which is our right hand side. It just need a logic for you to go through that correctly. If you practice more, you will actually get it right. Okay. We have one question that we need to continue with. It's in 12.2. This one is not the proving, but it's a general solution. Now, in general solution, this one, they strictly told you that this is a general solution. Normally, they don't tell you. They'll just say solve for theta, solve for x, and so on and so on. You need to be able to figure out how to solve for that. So this one, it is 12.2, and then we are doing the general form. They say determine the general solution of, and they give us cos 2x equals 1 minus 3 cos x. Folks, they're all cos. There's cos x there, but there's cos 2x. So it means we have to change the cos 2x and make it something that has to do with x, because 2x is not the same as x. That need you to go to your formula sheet and then find out what cos 2x in terms of cos can be. And that will be 2 cos. So in my, it's going to be 2 cos squared x equals 1 minus 3 cos x. So now you have cos throughout. You can be able to put them in the same side. There's a square, so it's quadratic. You can be able to factorize. So let's put them all in the left, and then we can be able to factorize. Okay, this will be my plus 3 cos x minus 1 equals 0. And if we can factorize, remember, we need to factorize such that we can be able to get, okay, this is cos squared x minus 1 equals 1. Okay, so the minus 1 there would go that side, makes this one a minus 2. If you factorize them, we'll get 2 cos x, and there we'll have a cos x. If we multiply the 2 with the 2, we'll get to what we're looking for, which is 4. Subtracting it from 1, we'll get the 3, but we need to put the signs in between. So that is cos x is equals to a half, or cos x is equals to a minus 2. This one is not a solution because we cannot get an angle with a negative in terms of cos. So we're going to focus on this one. For general solution, we're going to say x equals to arc cos, which will give you cos to the minus 1 of 1 over 2 in your calculator, and this will be 60. Now 60 became your reference angle. Now if that's the reference angle, you're going to say x is equals to 60 degrees plus. We are talking about cos, so it's going to be 360 degrees k, where k is an element of integers. Now k can be any number that is integers from negative to positive numbers, including the 0. You go on and put 1 and put 1 and put 1. And some textbook will go on and say, because we said this is in the first quadrant, you can go in the fourth quadrant and also use 360 minus, for which is actually covered here. But if you write it, no one can penalize you. So it will give you 300 plus 360 degrees k, where k is an element of integers, because 360 minus 60 will actually give you a 300. So practically this is how you do the general solution if there's no boundaries given to you. Sometimes they'll give you a boundary, so you must deal with the boundary and get all those ones that they're telling you. Matrix, this is very simple questions that you just have to practice more and more and more until you get it right. Okay, thank you. Okay, Matrix, we're still doing that question 12 that we're talking about, but usually in your question paper it's going to be question 6. So that question that we just did now for general solution is 7 marks. Can you see 7 marks? It was very free for you to get it. Now let's go to this 12.13. In question 12.13, this is what we are going to get. Let's see, 12.3, which is 12.3.1. They said prove that. So we are doing too much of proof here. For angles A and B, obviously the left side must be equal to the right side. So let's write what they've given us. This is sine A divided by sine B minus cos A divided by cos B must be equal to 2 sine A minus B divided by sine 2B. Remember, angle A and angle B, they are not the same. So you must try and make sure that you put that in mind. Left side must be equal to right hand side. So let's pick whichever. I'm left-handed, so left is fine for me. I'll pick the left one because it's complicated. You can pick the right one, it's fine. So let's start with the left side. So my left-hand side is equals to sine A divided by sine B. Remember, guys, to recopy the statement so that when you make mistakes, we can be able to follow them. So copy it as you see it. So this is what we have. Okay, interesting. We have to look at the denominator first. So our denominators are sine B, cos B, for which when we have our numerators, remember we said this denominator divided by that denominator, we're left with cos B. So this is sine A, which is remaining there, and the cos B from the denominator, minus, the same applies, the denominator divided by this denominator, we're left with sine B, and multiply there, we'll have cos A sine B. If you look at this one, folks, it's similarly to what you have in your formula sheet. Go to the formula sheet, you'll see something like that. And this is the compound angle for sine. So this is sine A minus B divided by sine B cos B. Now, so far, this is what you have. And one will say, but I'm having sine B cos B, and there I'm having 2, and I can't deal with it. And it's not that difficult, guys. If we go back to our formula sheet, let's just write it as rough somewhere. If we go back to our formula sheet, we will find that sine 2 of a same angle. In this case, we are talking about B, because I want to do this one. It's actually equals to 2 sine B cos B. Now, if I want sine B cos B to be the subject of the formula in this compound angle, in this double angle, I must divide both sides by 2. So if I divide this side by 2 and that side by 2, there 2 will cancel and I'm left with sine B cos B, which is what I'm having there by the denominator. But this can be equals to 1 over 2 sine 2B. So it means instead of writing sine B cos B, I am going to write half sine 2B. So that's what we are going to do there. This is sine A minus B divided by half sine 2B. Now, if we are having half sine 2B, we already have our 2B, that's what we want. We are left with the 2. This is division. If we flip and times, the 2 is actually going to go up. So if that's the case, then it means that we'll have 2 sine A minus B divided by sine 2B. Voila, that is equals to our right hand side. And you are done answering your question. As simple as that. What you need to do is to focus on what you know and how can you relate it with what is given to you. And that's how we prove the left hand side and the right hand side information. Okay, folks. If we go to the second question, it is 12.13.2. Similarly, 12.3.2, I mean to say. It is a similar question, but you need to apply different content. But your formula is still important. So let's copy it down so that we can be able to talk about it. Sine 5B divided by sine B. One is saying, 5B? I have never seen that. But it's really simple. Just have to keep calm and focus. This is cos 5B divided by cos B. That must be equal to, let me write it down here. It must be equals to 4 cos of 2B. So we can choose whichever side as well. The left side is more complicated because it has 5 and so on. So I'm going to choose that because I see it's the one complicated. My left hand side, it's equals to sine 5B divided by sine B minus cos 5B divided by cos B. If you look at it, we are doing similarly to what we just have done now. Doing this, we're going to find our lowest common denominators first. It's going to be sine B cos B. There we will have cos B multiplied by sine 5B minus sine B multiplied by cos 5B. Still, if we look at this, it's the reverse of the compound angle of sine. So we need to take it back. How do we take it back? We just say this is sine of 5B minus B. Divide all this by sine B cos B. Now, what is 5B minus B? Remember, B is the same angle in this case, so it's going to give us 4B. So it means we are going to have sine of 4B divided by sine B cos B. We are kindly somewhere there because we have 4, so it's making us feel happy. But it doesn't really give us what we want. So having this 4, we're going to do what? We are going to expand this. Remember, 4B can be rewritten as 2 times 2B. So we are going to rewrite that like that, as 2 times 2B. If we rewrite this as 2 times 2B, it means we are having a double angle of sine with 2B, not B. So we are going to write it just below. So this is the same as 2 sine 2b cos 2b. That's what it means. Okay, and after that, remember we said sine b cos b can be written as half sine 2b on the previous question. So that's what we are going to use here to substitute as we did. So we're going to say this is divided by half sine 2b. Now we are multiplying now and we are dividing. So that means that sine 2b can actually cancel with the sine 2b. And we have 1. Now we have 2 divided by half. If we flip and times, that will give us a 4. And now it means we are having this 4 that we have there. Multiply that 4 with the cos 2b, and that will give us our solution. Let's see if we can write it there and if it can be visible. So we have 2 multiplied by 2 over 1 multiplied by cos 2b. And now that gives us our solution as 4 cos 2b, which is our right-hand side. Okay, then you have answered the question, and that's what they wanted you to do. It's logic and need practice. It's not that much challenging because it's about 3 marks to get. So you can get it right if you practice more. Okay, matrix, we're still doing these proofs. I said to you, you must make sure that you practice a lot and then you'll get it through. It's just a logic. So now there's another question that was extracted from another question 8. But this question, it is still on what we guys are doing, the proving and the general solutions and those kind of things. So let's start with it. This question was taken as 8.2 because the other part we have done them, so I didn't feel of repeating the same things afterwards. So in 8.2 we're saying, given an expression, consider this expression, 1 minus cos 2x minus sine x divided by sine 2x minus cos x. And after given that expression, we must prove something on it. This is the expression minus sine x divided by sine 2x minus cos x. Now, in 8.2.1, we were told that we need to prove that this expression will be equals to tan x. So we need to prove that our left-hand side equals the right-hand side. Again, you take the complicated side, uncomplicate it, and make sure that it gives you what you're supposed to get in another side. So in this case, our complicated side is our left-hand side. So left-hand side will be equals to 1 minus cos 2x minus sine x, all divided by sine 2x minus cos x. So you need to change things such that they will give you what you are looking for. Look at it. Your tan, it sometimes consists of sine in the numerator and cos in the denominator. So try to figure this out until you get there. First of all, if we change our denominator to be 2 sine x cos x minus cos x, we can again take out the common factor of cos, then we're left with 2 sine x minus 1. Now this is what you are trying to figure out at the top. How will you do that? So first change cos to be in terms of sine. And from there, we will take it. So we have 1 minus. How do we change cos to be in terms of sine? You go to your information sheet. This is your key. In the information sheet, the cos in terms of sine will be 1 minus 2 sine squared of x minus sine x. And then you simplify. Remove the bracket. It means we will have 1 minus 1 plus 2 sine squared x minus sine x. All this will be divided by 2 sine x cos x minus cos x. Now, if you look at this simplification, 1 minus 1 will give us 0, and 2 sine squared x can be rewritten as 2 sine x multiplied by sine x. So we'll take out the common factor of sine x. Then we remain with 2 times sine x minus 1. As a denominator, we are going to take out the common factor of cos x. Then we remain with 2 sine x minus 1. Can you see? The logic just happened. So the brackets now are the same. We can therefore cancel them so that they can give us 1. This bracket and that bracket, they are the same. They'll give us 1. And now this will be equals to sine x over cos x, which is the identity of tan x. Now that is equals to our right hand side. And you are done to answer that particular question. So can you see how you can go about that question and you will get it right as it is? Go on and revise, practice, practice, practice. You'll get it right. 8.2.2. They're saying the above expression is undefined if sine 2x minus cos x equals 0. Solve the equation through the interval where x is greater or equals to 0 or less or equals to 30. So your solution must lie between that. So let's do it. 8.2.2. We are told that it's undefined. So undefined is when the denominator is equals to 0. That is where undefined is. We must solve for x. Now, look at this. We have sine and cos. We just said these two are somehow married. So we can put them in that statement. So let's put sine 2x equals cos x and decide whichever you want to change it to 90 minus. Folks, we must use the angle of 90 minus because it's in the first quadrant and all ratios are positive in the first quadrant. So I will decide to change the cos. For some reason, this will be sine of 90 minus x, and that is still sine of 2x. Now, the moment we have the same ratios, we drop them and we focus on the angles. So the ratios are not important anymore. What is important is our angle. So 2x, it's going to be 90 minus x, meaning that 3x is equals to 90. Now, this is our reference angle. Remember, we are looking for them in the boundaries. What is the boundaries? We are looking for them in the boundaries of, sorry. We are looking for them in the boundaries of x being greater equals to 0 degrees, less equals to 360 degrees. So this is where our answers, our solution must fall within. Can be 0, can be 360. So how do we do that? We're going to use it as if we were doing general solution. We're going to say 3x is equals to 90 degrees. We are dealing with a sine, so it's going to be plus 360 degrees k, where k is an element of integers. And then we start using the calculators, put those integers inside so that we can get the 0. First, we start by putting a 1 there. We start by putting a 2 there and go on and go on and go on. The negatives and all those values. So if I put a negative 1, my answer will be negative. So it's not part of the solution. If I put a negative 3 and so on. So first of all, let's divide everything by 3 to get x, because remember, we are solving for x. So we have to have it as x. So divide by 3, and divide that by 3, meaning the period has changed. So if we say 3x divided by 3, we remain with x, and 90 divided by 3, it's going to give us a 30, and 360 divided by 3, it's going to give us 120. So that is our new period, where k is an element of integers. Okay, Now we start doing what we need to do. If I put 1 here, so one of the solutions that I have is 30. K. If I put 1 at K, then my solution will be 120 plus 30, which is 150. If I put 2, I'll have 240 plus 30, then I'll get 270. If I put 3, I will have 360 plus 30, which is more than the boundary. So now my solutions, therefore, is going to be 30, 150, 270. For now, those are my solutions. That is between the two boundaries from 0 to 360 degrees. And that's how you answer this kind of question. It is 4 marks, your reference angle, and your solutions will be having those marks. And that is the end of this question 8. You need to be careful and make sure that you understand when there's a boundary and when there's no boundary to answer the general solutions. Thank you. Okay, matrix, we're still in trigonometry, and this is one of the questions that has more marks for your final examination. Now we are doing the revision for 2019 revision. So let's look at this exam question paper that we have found. It is in question 6, which is usually having your graphs for trigonometry. So remember, when we deal with graphs for trigonometry, we did deal with the mother function for both sine, tan, and cos. So you need to plan so that you can remember what is the shape of what you are looking at. If the graph is cos, what is the shape that you are expecting? And if it's sine, what is the expected shape? So that is the key to these questions. So let's see. If that is the case, then we are going to have the graph as it is. It's in question 6, as I said. So that's question 6. Let's write it down. And our graphs are like this. Now, looking at these graphs, folks, it is two shapes that looks the same. But we're talking about cos and sine. And these two graphs are actually the graphs that we need to deal with. If you look at it, we do have the cos and the sine, but we need to look at what happened for the mother function to become what it is in this case, because the graph has been transformed from what it was to something else. Okay, so let's read the statement. They said, in the diagram below, the graph of f of x equals cos x plus q. Now they are telling you that the graph of cos, which was normally in this sense, so normally you know that your plane shape in terms of cos, you were supposed to deal with something like this. Now what they are saying is that for that cos graph, it's not like that anymore. What happened is it has shifted some other units like Q unit to either up or down. So you need to figure out if Q unit has shifted to go there or Q unit has shifted to go down. Anywhere down or anywhere up. So that's what you need to figure out at the end of the day. And they said there's a sine graph, and that sine graph, again, it was supposed to be sine x, but the angle has been shifted horizontally, not up and down this time, it is horizontally shifted. So what happened is that on that x-axis, something happened, which is your angle. So you will have, remember the mother function of it, it was supposed to be just that. So that's how it looks like in terms of sine. So this is your sine graph. But something happened such that this point came there or came there, went somewhere, so they shifted along the x-axis. That is what's happening to this graph. And they say, as they were drawn in this system, from negative 240 to positive 240. And they've given us a point of intersection at 0 degrees and 1 divided by 2. And also at 120 degrees and negative 1. Also 240 degrees and negative 1. So those are our intersection of the two graphs. So if you remember the mother function, then you can be able to push it up or down to figure out what happened. Okay. Now these graphs were generally given to us in this case. For the one of cos, it was given a name of f. So we know the f of x graph, it is the one that is cos. And for the sine, it is given a name of g. So we know the g of x graph, it is for the sine. What happened there? We will figure it out. Okay. Now let's go to the questions. We have figured out the shapes now. We can see up and down movement and the side movement due to the statement given to us. And they say determine the value of P and Q. Where is the P and Q? This f of x is in this case now, f at x is equals to cos of x plus q. So q is what we are looking for. And the sign is said g of x is equals to sine of x plus p. So we need to find out p as well from the given graph. Okay, now let's answer the question. My graphs are in this manner. My f graph is the one that is moving like this. Look at this, look at it, and look at that. Now, what do I know about my f graph? At the beginning, I know that my f graph was supposed to cut at 1. Start there, go down, and then go up. Like this shape. This is my f graph. But that's not what happened. If I look at my f graph, it's like now it didn't start where it was supposed to start, but it started somewhere. And what does that mean? It means that my graph has moved either up or down by a particular unit. Now, let's see. If this is what is happening to my graph, what I expected, so let me try to do what I was expecting is that there, and it was supposed to go down and the other side. I'm talking about the f graph, which is this graph there, this graph there, this graph here. So this is my f graph. Can you see? Now, the point that I was thinking it was supposed to be at 1, it is now at 1 over 2. Now, what does that mean? If it was supposed to be at 1, it is now went to 1 divided by 2. So this is my 1. Instead of being here, it is now here. Now my graph is starting there now. What is simple means that it means that my graph has shifted 1 unit downwards, half units downwards, because this was 1 and now this is half. Moving from 1 to half, you had moved a negative half. So what is the value of q now? Our value of q is going to be negative 1 over 2. So that is one of the solution is 6.1. Q is equals to a negative 1 over 2 because it shifted half unit down. If it shift half unit up or any other unit up, we use a positive. Now it's down, we use negative. Okay. Now if we go to the G, because we're looking for P in G, it means we are going to go there and say, okay, if I look at my G graph, which is this one, normally this point here was supposed to be at 0, which is what I've said here. But now it's not at 0, it is where? At half. Now what happened? Remember the P I said is shifting the graph in this direction. So it's horizontally movement, not vertically. So it's moving in horizontal way. Now you have to figure out what happened for it to move where it's supposed to be. Remember that this was supposed to be 0 and that was supposed to be a 90. This was supposed to be a 270 and then 360, for which this is a normal graph or matter function of the graph. But for now, what is happening is that it has moved to this point. So you need to figure out what happened to the one that was 0. If you look at it, the 0 is where 30 is instead of where 0 is. So if that's the case, it means that your 0 there had moved to this direction. This point had moved this direction. So it moved to the left. How many units? 30 units. And how does it move to the left? It means that your P now is going to be a negative 30 because it's going the negative direction. So you're going to say P is equals to negative 30 degrees. So in terms of your equation, you are going to rewrite it in a different manner, that this is f of x equals cos x minus a half. And the other one for sine, it's going to be g of x, it's equals to sine of x minus 30. No, plus 30 because it's going to the left. So it's a minus 30, but inside here is plus 30. Why? Because when I say x plus 30 equals to 0, my solution will be x is equals to minus 30. That is why your P is equals to a negative 30 in this case. Okay, so the movement, therefore, it's x equals negative 30. It's moving 30 units to the left. That's what that means in that case. And just by doing this inspection, they will give you your full 4 marks because they know you have done something up and down, going sideways, and whatever it is that you have done to get the value of the P and the Q. Okay, folks? 6.2, they said Determine the values of x in the same interval, negative 240 to 240, for which I kind of like these questions, but then it's not giving what people are expecting. 6.2, they're saying for which f of x is greater than g of x. What does this mean? They're saying if you look at your graph as it is, where will you find f of x graph on top of g of x? That's what the symbol means. The greater than means above. So in this case, it means on top of the other graph. So where am I going to get this one greater than this one? In other words, where am I going to find f of x on top of g of x? Okay, let's check. Our f of x graph, we are repeating to say this is it. If you look at it, this is our f and this is our g. Now, where will we find f on top of g? This is our g here to there. Okay, where x is negative 120 degrees to 0 degrees. That's where you'll find your f on top of g. So that's how you'll answer your question. So this is x will be greater than negative 120 degrees and less than 0 degrees. And they give you 2 marks just by saying that. So you need to be able to read it off to be able to say that this is the solution. So it's negative 120 degrees less x less 0 degrees. Okay. And they said, the last question says that describe a transformation. Now you have to say what happened. Describe a transformation that the graph of G, which is this graph, undergoes to form the graph of H, which now the graph of H is written in the form of H of x equals negative cos x. Now they're saying, what is it that can happen to end up with that sine x plus 30, moving away whatever happened to become h of x is equals to negative cos x. Now, first of all, what is going to happen is that you will have to have 90 at some point. If that happens, then it will do what they want. Now, what is going to happen to g of x? That is 6.3. So I'm going to put that g of x down for us to move it to h of x. That is our g of x, x plus 30 degrees. If I want to make it h of x, I need to have it as somehow it must have 90. So if I have sine x plus 30, and to make it 90, it means I'll have plus 60. So what is happening now is that my equation had moved, or my graph had moved from where it was another 60 units to the left. So it has moved another 60 units to the left. From the 30 to the 60, it became 90. So this is going to be sine of x plus 90 degrees. And that's what we have. And that is going to be sine, it's going to be cos of x. Because 90 plus x is in the second quadrant where sine is positive and will give you the answer. But remember they said it must be, what happened for it to be negative? So what happened again is that this whole thing was flipped upside down so that it became a negative. So it will accommodate that negative cos x. In explanation of words, what you are going to say is that there was a horizontal shift to the left by 60 units. And also there is a reflection along the line y equals to 0. So this, its solution is therefore in the case that you will be talking about the shift horizontally 60 degrees to the left. And another one is that there's a reflection along line y equals 0 or the x-axis. So you can use line y equals to 0 or x-axis. So these are the 2 explanations that they wanted you to do, and it's 2 marks. So each of them have 1. In calculations, this is what is happening for you to end up there, and the description of the calculation is that. Folks, I guess you have understood, or you can try and practice until you can understand trigonometry, which has many marks in your paper 2, and it will have more marks in your final examination. And that is the end of trigonometric revision. Thank you. Good day, grade 12. We are doing Euclidean geometry revision for 2019. We are doing this with Thandi Khoza, and Euclidean geometry is one of the topics that need you to be straight and focused. So how do you focus this one is you have to memorize or master all your theorems from the first theorem to the last theorem. In grade 12, we have plus round about 9 theorems that you have to understand, know how to use them. So folks, let's try and see what questions that are extracted from previous question papers can do in these terms of geometry. Remember, if you have to answer the question, you must be able to relate with your theorems, which applies from grade 11, from grade 10 actually, midpoint theorem, to the last one, which is proportionality and similarity theorems in grade 12. So you need to be able to look at them in that direction. Okay, this question normally it comes from question 8, question 9, and sometimes 10 and 11, depending on the examination paper. But now I have categorized it differently. Now the one that I'm going to do here in my space is said to be question 2. So this is, let's try quickly to draw a shape that is given to us. Remember, my shape won't be as perfect as what you will have in your books, because they will give you these shapes in the answer book. So you have to try and work around. I'm drawing it out so that we can be able to work around it together instead. So this is my center there, and then I have my circumference there. So this circumference is V, that is 0, that is O, and this is 48 degrees, that is 2, and okay, there's a line there which is coming from there to there, then that is 2 and 1, and this is U. This is 120 degrees, it's T, and then we have a tangent there, which is a line that is drawn from that point. So let's try to draw the tangent there, the top, it's cutting there, and that tangent is called PKR. So the tangent is PKR, and it has been labeled 1, 2, 3, 4 up to 5. So it's 1, 2, 3, 4, 5. Okay, that is what we are having at this moment. Now, before we look at the question, you must look at the diagram provided to you and try to locate every information that you know about it before you answer the questions. Like normally I said, use different colors so you can be able to talk about what you have. So I'm having my colors that are different, and I have many of them. So you have to have your own colors as well. What is the information? In the diagram below, O is a center. Now when you hear center, you must remember the theorem that says the angle at the center is twice the angle at the circumference. So then that is one of the theorem that you have to remember. Immediately you hear the center of the circle, and they've given you KTUV. If you see KTUV, you need to remember for cyclic quadrilateral, because all the 4 points are on the circumference. That is cyclic quadrilateral. And then we are given the PKR as a tangent, and that is touching the circle at K. So you need to remember the theorems that has to do with the tangent. Remember, one theorem says the angle that is between the tangent and the chord is equal to the one that is opposite to that, which is subtended by that chord at the opposite segment. And that is one of the theorems that you have to remember. And one is the one that says the tangent is perpendicular to the radius. So those are the things that we have to know. What I'm saying is, at the end of the day, this angle that is here, we'll use this. If there's a chord, it means it was supposed to go, but we don't have the chord is this one. So the angle that is there is going to be equal to the angle that is there. That's what it means. The angle between the tangent and the chord is equal to the one that is opposite to it. Same applies to the other side if you have the same situation. And also the angle that is between the tangent and the radius, this is it, it's going to be 90 degrees. So you have to remember those kind of information while you are busy with these questions. Okay, let's now check what is given. OUV. OUV is 48. We have labeled it correct. And also KTU, where's K? KTU is 120 degrees. That is your first point of reference. So what is it that you are going to say now? You are going to do, answer the question. This question is very simple. They say, use the above information to fill in the missing information from A to E. So there's a table informed to you. You have to fill it in. Sometimes they give you a statement you have to complete with a reason, and sometimes they give you a reason you must give the statement. So the first question, which is number A, they say to us, what makes V, let's copy it down, angle V plus angle 120, which is this one, to be equals to 180 degrees, and also that is making V to be 60 degrees. So you need to give us the reason, and that's what they'll give you marks for. That reason for that point is just simple because the opposite angle of a cyclic quadrilateral are supplementary. So when you give you the reason there, you will just say supplementary angles. So it is the supplementary angles. You don't have to write everything. You go there and you look at your reasons and then you reason through those ones. Okay, number B. It says, what will be the reason of making K angle O U to be equals to 120 degrees? Now, where is K angle OU? This is K angle OU. What makes this angle to be 120 degrees? Folks, let's look at this. We said the angle at the center, it is twice the angle at the circumference. So this is the angle that we are talking about at the center. Let's call it O1. Okay, so if we say O1, let's write it here. If we say O1, it's equals to, remember this is the angle at the center, is equals to 2 times angle V, meaning the angle at the center is twice the angle at the circumference. By saying this, it means you'll have to give us a reason. Angle at center equals to angle at circle, meaning the angle at the center, it is twice the angle at the circumference. So remember this was given to be 60. You just saw it there. So this is multiplied by 60, which is giving us 120. So if they say, give the reason of KOU, which is the same as that one, why is it equals to 120? Your reason will be that the angle at center, it's equals to 2 times angle at circumference. And then you get your mark for that. So you need to be able to trace back the information. Okay. The third one, they said UO, this is UO, it's equals to OK. Those are the radius. And if that's the case, what will be U2 equals to? Now, if you look at what we are talking about here, it is this line U, O, and OK. So this is the triangle we are dealing with now. And they say, what other angle can be equals to this one? So if those two are equal, it simply means that if UO it's equals to OK, because of the radius, it means that U2 as an angle will be equals to K4. Oh, K3 as an angle. Just because they are base angle that is equals to opposite to the other angle. So in reasoning, you will say these angles are equal because opposite side equals opposite angles. And that's how we reason it. So that one will be equals to this other one. Okay, they are equal just because this line is equals to this line. Okay. And K1 is equals to 78. If you look at this, K1 and 2, they are both equals to 90 degrees. Now, if K1 and 2, they are both equals to 90 degrees because of the Tan-Code theorem. How would we find K1 equals 76? Now, look at this from there to there. Remember, we know what O1 is. O1 is the same as 120. So this angle here is 120 degrees. What we are missing is this two. In triangle UOK, the sum of the angles inside is 180. But U2 is the same as K1. So as K3. So it means that they will share the remaining 60, meaning this is going to be 30 and that is going to be 30. If we add them together, they'll give us the 180 degrees. But K1, it's going to be equals to U2 plus 48 because of Tan-Cod theorem. So you're going to do that, or you're going to write it like that. It is K1 equals to 48 plus U2, which is 30, because of the tangent and the Cod theorem. So you can just say Tan-Cod, and that makes it 78 degrees. So you have given the reason of why is it equals to that. And they come and say why K2 is equals to 12. Remember K2, folks, it's there within the 90. So K1 plus K2 is equals to 90 to start with. K1 plus K2, it's equals to 90 degrees. And if that's the case, it means this is because of what? The tangent is perpendicular to the radius in this case. So K1 is 78, we just found it, plus what we are looking for is K2. And now to find K2, we are going to say 90 minus 78, for which we'll get 12 degrees. And in that way, you would have got your 5 marks free and straightforward. What you need to do here is to practice your theorems and make sure that you master them and you understand them. Folks, this is not that difficult. What you need to do is to understand your theorems. Thank you. Okay, matrix, we're still in geometry. Remember I said geometry has more marks. You must. It's a must that you master it if you want to go on doing this interesting subject, which is mathematics. So in geometry, the key is make sure that you look at the diagram together with the information before you go to start looking at the questions. In that way, you fix everything and then eventually you've answered the first question. So let's do the next one. In my paper, I have named it question 14, just for understanding. So it's question 14. In my question 14, then, I have given this statement. Let's see. The statement given to us, or let's first draw the shape as we did first. So we are drawing our shape. Remember, it's not up to scale, but we'll try to draw it as possible as that this is a diameter. And there is a line that goes from the diameter to there, and it comes to the center, and it goes to the circumference. Another line is going from the center and to the circumference and to the other circumference. So, okay, folks, let's continue. So now we have drawn that shape, and let's try to see if we have drawn it properly and label it as it is. For you guys, you shouldn't be worried because the shape will be drawn for you and in the answer book. So there's no stress. This is what the shape is all about. It has been labeled in this case. This is 1, this is 2, and they have been called X as well. And this is B, and that's line A. O is parallel to line DC. And there's E here, letter E, with 1 and 2. And I guess that's how it has been labeled. Now, before I look at the question, this shape of mine, and we have to look at what the information given. They said, in the diagram, O is the center. Now we know if you have the center, there's an angle at the center towards the angle of the circumference. That's the first thing. And if the center then, and they said A, B, C, D are the points on the circumference. They're not necessarily they're exactly quadrilateral, but they are on the circumference. So you can look at them and see if they are actually in the circumference. And they said to you, CD is a diameter. Now, having a diameter, it gives you the power to say, I have the angle 90 at the circumference. So having this as a diameter, this angle there will be 90. Angle A1 plus angle A2, it's 90 because it's subtended by the diameter. So you need to note that down so you can be able to remember while you are working on it. Now, more information given to us. They say the chord CA intersects the radius. We can see that, and AB is drawn. Okay, these are all straight line. They said again, A2 is equals to X, while CD is parallel to AO. So we have labeled everything. We can therefore go and check the questions. Now let's see what the questions are saying. Give a reason why. Now we are still reasoning. This is question 14, as I said. My 14.1 is, we are still reasoning. 14.1, we must give a reason why C1, so angle C1 is equals to X. Now where's X? This is where my X is. Can we use different pen? This is where my X is. Now they are saying, give a reason why this A2 is actually equals to angle C1. Folks, we have been given the parallel lines. Let's start using them and see what it will give us. Remember, in parallel lines, we have three conditions. One condition is that alternative angles are equal. The second one is that corresponding angles are equal. And the third one is that co-integral angles are supplementary. Now we are talking about the other one. So let's look at this one. If I throw this line straight there and go down and go this way, I'm having this angle there equals to the angle there. Okay, I guess that's clear. If I draw another line, starting from 0, I go up to A and I go down to C1 and I go up. You can see that C1 is equals to X indeed, as they say. Now, what will be the reason? The reason for that is that there is alternating angles that are equal. And if alternating angles are equal, you always have to specify the parallel lines that you are talking about. And this equal sign is also important. So you need to say AO is actually parallel to CD. And then that's how you should reason that part. Okay, the second one, they say, explain again why C2 is still going to be equals to X. Folks, look at it. We are looking at C2 now, 14.2. C2 is equals to X. Give us a reason. Look at triangle AOC. The triangle we are talking about now is AOC. This is the triangle from A to O to C, and close it. Can you guys see that CO is equals to AO? Because now these are the radius. This line is equals to that line. They are radiuses. So if these two lines are equal, they are opposite the angles that are going to be equal as well. So that means C2 is equals to X because it's the angles that are opposite equal sides. So let's write that because that is the reason. It is going to be angles opposite equal sides. And one can simply say because OC is equal to AO, and the reason will be radii. Either one of these two reasons will give you a mark. Okay, folks? And it's very simple for you to just follow as long as you know the theorems and the information that is needed. Okay, let's go to the other question, which is 4.1.2. So, oh, no, this is 4.1 and this is 4.1.1. So let's label it properly. 14.1, 14.1.1 and 14.1.2. So we are going to 14.2 now. Okay, that's too much 14 point something point something. Going to 14.2, let's look at the information. Determine giving reason. Now you actually have to do it. And the 3 marks, the 2 marks, that's where they're coming. Determine with giving reason the size of the following. In terms of X. Remember, in terms of means that X must be there. Not necessarily that the answer must be X, but whatever you write, X must be there. And the first one is A1. So let's look at it and see how we're going to get A1. So we need to find A1 in terms of X. This is a question at hand. Let's figure it out. Where is A1? A1 is just there. Folks, remember we said A1 plus A2 is equals to 90 degrees from the beginning and from the statement. The reason was because it's the angle subtended by the diameter or semicircle. So you can write one of that, semicircle, angle subtended by the diameter. So we know that A2 is already equals to X, meaning that A1 will be equals to 90 degrees minus X. And to be surprised, this is 3 marks. So you see you got your statement, your reason, and your solution having the full 3 marks. Okay, Now determine the value of O1. We just have said that O1 is actually equals to angle D. But angle D is equals to X. But angle D is equals to X. How can we find this one? If we say the angle at the center and the angle at the circumference, let's look at that. Our angle at the center, it is O1. Our angle at the circumference is C1. So C1 and O1 will give us something similar. Okay, let's go to D. How will we get to D? If we have, okay, we'll use parallel lines. D is also equals to O1. So let's write that down. It is 14.2. O1 is equals to angle D. And if O1 is equals to angle D, we just have said that this is because of the alternating angles. Let's write the information down. Alternating angles are equal because AO is parallel to CD. That is our first information. Let's look again on the other one. Remember, angle D, angle O1 and angle O1 and, okay, let's see. No, it can't be angle O1 because it's going to the center and the second. Yes, angle O1 and angle C1, they are the same as well. So O1 is equals to C1 because of the angle at center equals to twice angle at circumference. Okay, so angle O1 is equals to 2 angle C1. Now, angle C1 back then, in 14.1.1, we have said that it's equals to X because of the alternating angles. There it is. Okay, if angle C1 is equals to X, it means that angle O1 is also equals to 2X. Why? Because C1 is equals to X and O1 is equals to 2C1, meaning that O1 is equals to 2X. So that's how you have written this one in terms of X. Your angle O1 is equals to 2 times angle C1. Okay, which makes your angle D to also be equals to 2X. So you have killed two birds in one. If that question was asked, you could have found it as well. Okay, the last question, they said you must find O2. One will be saying O2 is far out from what I'm looking for. Yes, it is. But let's look at triangle CAB combined together like that. If we look at that triangle, we can be able to find angle B in that triangle. Okay, let's write it so that it's simpler for us to understand. 14.3, let's look at the triangle CAB, whereby angle A in that is 90, angle C2 is X. So it means that angle B will be equals to 180 degrees minus 90 minus X. That is the angles of a triangle. Okay, for that matter then it means that angle B is also going to be equals to 90 degrees minus X. In other words, angle B is the same as angle A1. It is 90 minus X, which is making sense because OA and OB, they are radiuses, which makes these two lines equal. And if they are equal, it means that they can give us what we are looking for. So this line is that line and it's that line. Okay, so we can now go to triangle ABO. That is a small one. Remember we said that angle A1, it is 90 minus X. And also angle B is 90 minus X. Now what are we looking for? We are looking for angle O2 according to the statement. So this is what we are looking for. Now using that triangle, ABO, angle A1 plus angle B plus angle O2 is 180 degrees. That is the angles of a triangle. Okay, the sum of the angles in a triangle, right? These two, they are the same. So we'll have O2 equals 180 minus, let's write it like that, 90 minus x, and also minus 90 minus x. Let's see what is coming to happen here. We will have 180 minus 90 plus x minus 90 plus x, and that gives us 2x. If you have looked at it in a different direction, you could have found out that O1 is actually equals to O2 because they are both equals to 2x, and you could have given the reason that makes them the same, and that is the solution to that question. There's one left, and that one is directed to for you to conclude in a way that one of the space is a cyclic quadrilateral. It's like a conclusion from what you have done. If you have done everything properly, then you can be able to conclude. Let's look at it. For which value of x will A, B, or E be a cyclic quad? Now, there's three conditions in terms of cyclic quad. One, the opposite angle of a cyclic quad must be supplementary for whatever quadrilateral to be a cyclic quad. Two, the exterior angle of any quadrilateral must be equal to the opposite interior angle for whatever shape to be a cyclic quad. And the third one is that it must subtend the angle. So the diameter or the chord must subtend the same angle, or the arc must subtend the same angle. So let's see which one can do that. What are we looking for? It is A, B, O, E. Let's trace it. A, B, O, E. A, B, O, E. So we are tracing this one. If this shape there have something of what we have talked about, therefore we have a cyclic quad. Now let's look at this. The line that is having, remember we said O1 and O2, they are equal. And what are they equals to? They are equals to 2x. And what is going to be A1 and A2? So if you can prove that A1 plus A2 is the same as O1 plus O2, or when you add them together, they will give you 180. Then you have proven. So let's see if that can happen. It is 14.3, this question. So the 14.3, we are trying to prove a cyclic quad. So what is A1 plus A2 plus O1 plus O2? What are they giving me? So that's what I'm looking for. But I'm aiming for them to give me 180. If they can, it means it's true. What is O1? O1 is 90 degrees minus x. And what is A2? A2 is given as what? A2 is given as x. It was a given statement. And what is O1? We have found O1 to be 2x. And what will be O2? We have also found O2 to be equals to 2x. So let's see if that's what is going to happen. We are having 90 minus 4x in a way. 90 minus 4x is what we are having in this case, meaning that A1 plus O2 plus A2 plus O2 plus O1 gives us something like, okay, let's rephrase. We are talking about A1 and together. A1 and A2, it's actually 90 because of the diameter. So the two of them will give us 90. And how much will be this one, which is O1 and O2? Now, in O1 and O2, we need to figure out if we can get a 90 from this one. And if that's the case, it means we know that the two of them will give us 180. And then, if that's the case, it means that this is a cyclic quadrilateral. And one other way is that we can prove that the angle that is outside here is also equal to the angle that we'll find there, which is 90 minus. If that's the case, then we get the solution. One other way is that we can prove that this angle there, which is angle E2, plus the angle B are giving us 180. So those are the three conditions that we are looking for. The whole of angle A is equals to 90. So let's look at this one. The whole of angle A, it's 90. Remember, we are talking about A, B, O, E. If I'm not mistaken, yes, A, B, O, E. The whole of angle A is equals to 90 degrees because of a semicircle. Now we are looking for angle O1 plus angle O2. What is it that they give us? We have solved that angle O1 is the same as 2x. And angle O2 is the same as 2x. So it means that O1 plus O2 is equals to 4x. That's what we are having. And how can we represent this to be 90? In this case, it's not really what we are looking for. If this is 2x, this angle there will be 180 degrees minus 2x, because that is the angle we are talking about. Okay. If this angle there plus this angle here gives us 180, then we have a cyclic quadrilateral. Now that's what we are saying. So let's say the whole of angle A, which is angle A1, it's plus angle O in this, which is angle O1 plus 2, will be equals to 90 degrees plus 4x. Now, if you look at this statement is not giving us a cyclic quad, but they said for which value of x, like whatever value of x that you can put in, such that A, B, or E is a cyclic quad. So after you have found this one, you need to figure out what value of x that you can put there, multiply it by 4, and you will get a 90. That's what they're saying. What is the value of x, or what value can you put? You multiply it with 90, and then you get to the solution. So let's see, if I say 90 divided by 4, I'm getting something like 22.5. 22.5 is then A, B, or E is a cyclic quadrilateral. So they wanted you to solve for x, or to find any value of x that when you put it here, it will make these two information valid to give you 180. So it means if I add them, I must get 180. That is why you have to come up with the value of x, because they said for which value of x will A, B, or E be a cyclic quad. And sometimes they don't ask it like that. They'll just go straight and say, prove that this is a cyclic quad. And they need you to look at those boundaries and make sure that you get it correct, like the supplementary, the exterior angle, and the same segment. That is the end of this question. Thank you. Okay, folks, we are continuing with the revision of geometry. Remember, geometry can be understood only if your theorems are at par. So you need to understand your theorems very well and master them so that you can be able to answer the question. In my questions, I have categorized this one in question 21. So, but I have chosen the 21.3 going down so that we can check what is important, because this is one of the simplest questions that we need to look at. So we're looking at question number 21. Okay. In this question, we are given a diagram again. Remember, this is geometry, so it's all diagram all the way. So we have the diagram with a cyclic quadrilateral. There it is. And our cyclic quadrilateral is a bit not up to scale, but we try to use it so that we can be able to be visible. You need not to worry, because you will have the answer book that has this drawn, smart, and smooth. Mine is just for your understanding. We're given that this line is parallel to that line, and that is line D, not B, that is line D, and that is line E. That is our C, B, and A. And it's labeled, this line equals to that line. So BE is equals to DE, and also that this line is parallel to BA or BC. What else? It's labeled that this is angle 1 and that's angle 2. This is 1, 2, and 3, and that is 1, And 2, the whole of angle E is equals to 70 degrees. That is what is given to us in the shape. So let's read the information, associate it with the shape, and see what is coming on. In the diagram below, BAED is a cyclic quadrilateral. Now, if that's the case, it means we're going to try to look if we have these three things that we have talked about, opposite angles being supplementary, the exterior angle equals to the opposite interior angle, and if we have the one that is subtended by the same chord or the same arc. Folks, let's try to see what is given more. So with the cyclic quadrilateral, we have that information in head. With BA parallel to DE, so with parallel lines, we try to look at alternating angles, co-interior angles, and corresponding angles. And A angle ED is equals to 70. We have labeled that there, so it's fine. We have a tangent that is D. It's touching the angle at D, so this is our tangent. Just didn't continue, but it is a tangent. It touches the circle once. So let's try to see if we can allocate the information. This angle there is 70, and that will make the angle there to be also 70. An exterior angle equals to the opposite interior angle. And we are given that this line is equal to that line, and also we are given that we have alternating angles and other factors of parallel lines. Okay, now we can go to questions. Calculate with reason the size of the following angle. Now, one angle that we need to find is angle A. Now, if we look at our angle A, it's that angle there by the corner. And we need to find what is equals to that angle, because we have to do it with reason to find this angle. So let's see. If we look at angle E and angle A, they are both inside a parallel lines. And if they are inside parallel lines, it means that we have co-interior angles that are supplementary. They are not equal, folks. They are supplementary. So let's write it like that. It is 21,3.1. Okay, so it's A plus angle E, which is given to be 70. They're supposed to be supplementary, meaning that they're supposed to be equal to 180 degrees. Why? Because they are co-interior angles. Why? There's parallel lines, D, E, it's parallel to A, B. Simple as that. Okay, angle E is given to be 70, so that means that angle A will be equal to 180 degrees minus 70, which is 110 degrees. And then you get your 2 marks. Can you see how simple this can be, folks? So that's what you do, and that's how you get to the solution. Okay, the question 2 there says, write with reason the size of B1. I think we've already done that. If you look at it thoroughly, you will see we have done that. Now, B1, this is 21,3.2. So B1, we have said that already, it's going to be equals to 70 degrees. The reason is that we have a cyclic quadrilateral DEAB. There's an exterior angle equals to the opposite interior angle. So this is equals to that because the exterior angle of a cyclic quad equals the opposite interior angle. Then you have your 2 marks. Can you see that is simple, quick, and straightforward? Now find D2. They want you to find D2. We are playing around the same numbers if you look at it. Now can you see that D2 and A, they are opposite to one another? Because of that fact, it means that we're going to say that A plus D2 must give us 180. They are supplementary because opposite angle of a cyclic quad equals 180. So we're going to say A, that's our angle, plus angle D2 without D1 must be 180 degrees. That is opposite angles of a cyclic quad must be equal to 180. So A is, we have found it to be 110. So it means that D2 is equals to 180 minus 110. That gives us a 70. Even better, you can do it in another direction, or you can use these angles that we are having there and that one, using the parallel lines, so it can go with a Z. Just that the Z is not looking like a Z, but it is a Z. If you move from C to B, you go up, you go to E. So you can see that these two are alternating angles. So you can use that alternating angles and then you get it to be 70. Straightforward. Anyway, any direction, as long as it's mathematical correct, it is true. Remember, geometry have different ways of answering the question, so you can do that as well. Okay, 21.3.4. Let's see what they want us to do. They want us to find B2. Wow, B2 is just here. Remember, we found that D2 is the same as 70, so let's label that. It's very good, and it's a better way to label your angles as you go, because if you label them, then they give you an idea of what is needed after. If you label them, you can be able to focus on the solution. Now, we are looking at B2 now. Look at it. B2 is just there. Remember that this side DE is the same as DB. Now, if that's the case, we can be able to find our B2 in using this triangle. How? Angle D2 is the same as angle B2 because the sides are equal. Now, how do we write that in terms of maths? We are going to say D2 equals B2, and the reason will be these are the angles that are opposite equal sides. Remember the sides that are given to be opposite, to be equal. So then B2, it's also going to be equals to 70 degrees. How nice. This is simple and straightforward. Now, how do we find D1? Because D1 is one of the questions that we have to answer as well. D1 is just there, outside our cyclic quadrilateral. But this is not a straight line. So you cannot say that an exterior angle is equal to the opposite interior angle. However, this angle D1 here, it is on the tangent DC. Folks, make sure that you note this. There is no information that is given for geometry and it's never used. So everything that is given must be of use. We haven't yet used a tangent. If you forgot how to do it, you will go back and say, what did I use? Parallel lines, yes I did. Opposite angle of a cyclic quad, yes I did. Did I use the fact that I was given a tangent? No. Then tangent need to be used. So it means that you look at the angle between the tangent, which is CD, and the chord, which is DB. Must be equal to the angle that is subtended by the same chord on the alternative segment, which is E1. Okay, so that's where we start. It is 21.3.5. We will say D1 is equals to E1. The reason is tan chord theorem. Okay, now let's work it out. Remember, in triangle DEB, we already know that the angle B2 is also 70. So we are just looking at angle E1. So we can use that. Okay, in that triangle BDE, E1 is going to be equal to 180 minus 70 plus 70, which is 140. Then it means it's going to be equal to 40. So now we know E1 is 40 degrees. Only this E1 is 40 degrees. Now, if E1 is 40 degrees, we said E1 is the same as D1. Therefore, our D1 is going to be 40 degrees as well. So let's write it like this. Therefore, D1 equals 40 degrees. You need not to put the reason again because you've already done that for D1 and E1. However, you must put the reason for doing that, which is the angles of a triangle. This is geometry. Everything you do must have a reason. Without a reason, you are subtracting yourself marks. Make sure that you write it smooth and clear. Folks, That is how you will answer this particular question. And it's a straightforward. What you need to remember again is to practice, 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 and make sure that you understand your theorems, focus on them, and be able to reply when the question comes, needing you to answer the theorem. So geometry is all about theorem mastery. Thank you, folks. Okay, in this question, we have labeled it question 24, just to keep order, and then we can be able to find out when we are working it. So let's write the question number first. It's question number 24. And as usually, we have to try and redraw the shape and put all the information needed into the shapes before we try or we start answering. So remember, it's not up to scale, but it is the one that we can use for now. And you shouldn't be worried because it will come with the answer book. So mine, it's not up to scale, but there's a diameter there with a center, and there's a line going to the circumference, and also there. Okay, from this line, it has to go not passing through the center, but it goes to the circumference, and it goes back to the tangent, and also between the tangent and or between the chord, there's another line that is going to the center, and then back to the chord. Okay, practically this is the lines that we're having. So let's see if we label them, if we're gonna get it right. This is labeled S, and this is N, for which there's N1 and 2. That is O, that is T, with 1, 2, 3, and 4, for which 1 is labeled 85 degrees. So this is 85 degrees. Let's write it there so that we can remember. And then we have W there with 1 and 2. We have O there with 1 and 2. What else do we have? We have R. So this is our tangent, which is KR. There's P there with 1 and 2. With R, we have 1, 2, 3, 4. So it's 1, 2, 3, 4, for which 2, it's given as 30 degrees. So let's use a different color so we can remember that there's something that we need to use. The moment they give us values, it means that our answers must be in those values. So let's go to the information. See if all the information, it is in the shape. If not, we must put it in. Okay. They said the vertices of triangle. So when you're talking about a triangle, P and R. This is P and R. They are on the circumference of the circle with the center O. This is our center. Okay. Diameter SR, that's our diameter. Remember I said the moment you read diameter, you must go on and put 90 degrees so that you can remember that the diameter is subtended to the angle 90. Okay, SR is a chord and NP intersect. So they're intersecting with SR, with SR. This is intersecting with NP. So this is our NP there at T. They are meeting there. Okay, R2 is 30. It's labeled. T1 is 85, also labeled. And RK is a tangent. So we can see that this is our tangent. And there's many things that we can say about the tangent. So let's see if we go to the questions, what is it that the question is saying? Question 24.1.1. Remember, this is our question number 24.1. So there's 24.1.1. Question 24.1.1 says, what is the angle S? In other words, determine, stating reason, the size of angle S. Folks, can you see that angle S is this angle that we are looking for there? This is our angle S here. We are looking for it. Now, if we look around there, we are talking about this triangle S going to P, going to R, and then there with our diameter. Almost done, right? So if you have said something, it's actually I've given you the solution. So in this triangle, S is going to be found in this manner. So it's going to say angle S plus angle P plus angle R2 is equals to 180 degrees. Okay, this is the sum of the angles in the triangle. And angle S is what we are looking for. Angle P is 90 degrees. Angle R2 is 30 degrees. So we can do the algebra and find it out or figure it out. This is 180 minus 120 will give us a 60 degrees. In other words, we have calculated that angle S is now 60 degrees. If you look at it, my shape is very messy. I'm using all these different colors so I can be able to remember what is needed when I need it, okay? Or what I have done, where did I pass, and so on and so on. So what was given, I use red, and what I'm finding, I'm using a green pen. So you need to try and do that so that you can be able to separate them. Okay, the next one, they said we must find R3. Now you need to locate your R3. Our R3 is there. Can you see it? However, R3 is inside the triangle NOR, for which ON is equals to OR. So let's label that. Why? Because they are radius. Okay. And if these two, they are equal, it means that we can be able to find this one that is equal to that side. N2 is the same as R3. So let's start and see. However, we know that angle S, the whole of it, it's going to be equal to angle N. So the whole of N here is going to be 60 as well. It's subtended by the same diameter. So this whole thing there, it is also 60 degrees. Okay, folks. And if that is the case, we know that the whole thing there is 60, and there we are given to be 85. Can you see that we have this triangle NT going to R and closing it there? We have two angles that are known. We need one. So we can still use the same reasons to get to that one. In either way, other method can also be used. Apply, there's no problem. So that is 24,1.2. In triangle NTR. So we can say that so that we can be able to remember the triangle NTR. That's our triangle. Okay, N there, it's equals to 60. So we're going to say N, meaning N1 plus N2 plus only T1. So that is our T1 plus our R3. It's equals to 180 degrees. Angles of a triangle. Nice. Now we have N being 60, but we cannot just say N is 60. We must highlight it first to say angle N is equals to 60 degrees because it is angles at the same segment with what? With S. So you are telling the person that you just have known that N will also be 60 because they are in the same segment or subtended by the same chord, which is PR, with that one. So that is the reason we are saying it's 60. So it means that R3 equals 180 minus 60 minus 85. And you can quickly use your calculator or do what is needed to be done to get to the answer. So let's use a calculator. There's 180 minus 60 minus 85. We get it to be 35. So it means that R3 is equals to 35 degrees. And we have answered that question. Okay, anyhow, we can use other methods to find it, as I said. So this is 35 degrees, according to the angles that we have found in the triangle. Okay, now if we go on to the next question, we just have found R3 and now we want N1. Remember that R3 is the same as N2. And we said that N1 plus N2 is equals to 60. So if R3 is the same as N2, it means that N2 will be the same as 35 degrees. Then we can subtract from N1. So let's write what we are saying. It is 24.1.3. We are saying that N1 plus N2, they are all equals to 60 because of the angle at same segment. So that's what we have used at the top. And then N2 is actually equals to R3 because it's the angles that are opposite equal sides, or you can just specify the sides and say the radius. Now this is going to be equals to N2 will be equals to 35 degrees as well. Or you could have said N2 is equals to 35 degrees, so you are done. That's what we were supposed to find. I think we're finding N2. N2 is 35, but N1, it needs to be found. So this is N1 plus 35 is equals to 60 minus 35, which will give us N1 to be about 25. It is 60 minus 35, which is giving us 25. So therefore, N1 equals 25 degrees. And in that way, you have answered that question. So it's a focused question that you can get either way with finding it correctly. So it's not that difficult for you to get. We have found that, again, this is also our 35 degrees, which makes this one 25 degrees. Remember, the 60 is for the whole part. It's not only one. Okay. What else must we find now? We must find R4. Where is R4? This is R4. Remember, this is a tangent, and then this is a chord. So the angle that is there will always be equal to the angle that is subtended by this same chord at the alternative segment. So this is that angle we are talking about. So the angle P2 is actually going to be equal to angle R4. But we need to find angle P2 alone without angle P1. That's what it says. But we know that P1 and P2 is actually equal to 90. So we are looking at, we want to find this one alone, for which we can use triangle NPR. If we look at it, we can use that triangle. Alternatively, we can use SN arc to say if I move my hands, it's going to close at R, and if I move my hands there, it's going to close at P1, meaning that P1 is also going to be 35 degrees. These are subtended by the same arc. Okay, so let's write that. This is 24,1.4. So we are saying that P1 is equals to R3. So if P1 is equals to R3, it will be equals to 35 degrees because it is subtended by the same arc. Now we are talking about the arc because we are using the arc or angle in the same segment. And we said this is that. So it means that P2 will be equals to 90 minus 35. Because P1 plus P2, it is 90 due to the fact that it is the angle that is subtended by the diameter. So what is 90 minus 35? 90 minus 35 will give us a 55 degrees. Meaning that P2 is going to be equals to 55. And if P2 is 55, that means that R2 is also 55. So we'll say R4. So we'll say R4 is equals to P2, and your reason will be tan chord theorem. Therefore, R4 is also equals to 55 degrees. And in that way, you have answered that question. Nice and clear. We have one more. Normally, the last question is for conclusion. So the last question there, it might not take us a lot. Let's try to look at it. Let's say, determine whether, so it's whether or not, it can be or cannot be. NT is a tangent to the circle passing through NOR. Now let's check. The circle passing through N NOR. So this is what we are talking about now. NOR, we don't go there, it comes there, it goes there. So they are saying that we have to prove if NT, this line, is going to be a tangent to this if this is a circle. So if this is a tangent, it means that we need to have found that the angle that is N1, which is between the tangent and the chord, will be equals to R. And that is not the case because this is 25 and this is 35. So they are not equal. If they are not equal, it means no, NT, it is not a tangent. So you're going to conclude it like that because it's not. What are you going to say? You will say in 20, what is the question? Is 24.2. 24.2, you will say, let's look at the statement. You will say NT is not a tangent to the circle passing through NOR because N1 as an angle, it is not equals to angle R3. So if that's the case, then we cannot have it as a tangent. Only if they were equal, then we will have them as tangents. Can you see how you lose this last 2 marks? You just have to focus, practice, and try to relate your theorems and your knowledge to it and you get it right. Okay, folks? That is the end of this question, and I guess you have enjoyed the lesson. Okay, folks, we are on question number 17, which is the question that we have located. Remember, I said this question has nothing to do with the question paper. Your question paper finding question 8, 9, 10, and sometimes 11 for you to answer this geometry. Remember, geometry has too much marks. Actually, grade 11 work is about 85% of your final examination. So let's write this question 17 as we usually do. So it is question 17. First, let's draw the shape. This is a bit complicated shape, but I'll try to draw it as it is. It's a bigger and there's a smaller circle. So there are 2 of them which are intersecting at one point. So let's wrap that and try to do this. Okay, there is our intersection. And between them, there is a line, which is a straight line, meaning it's a tangent to both of them, but they will tell us on the information. Let's try to draw that straight line, goes up and down. And from there, there's a line that is coming from, there's another tangent there, which is moving there and intersect with this one. And from here, there's a line that is moving there to the circumference. And there's from the intersection to the tangent. And there's a line there, which is coming this way. It's a bit better. And we have a line which is moving from there to there. And another one that is moving from here, passing through the intersection to there. So this is plus practically what we are looking for in terms of the term. So let's label it and see if we did not leave anything out. This is P with 1, 2, and 3. This is T with 1 and 2. And we have R with 1 and 2. This is our Q. It is labeled 40 degrees. And this is line which is having a B. And that's N. And we have A, which have 1, 2, 3, 4, 5, and 6. So it means we have drawn it properly because that's what we need to say. It's like, as usual, we must go back to our information, meaning we go to the content given. In other words, you have to go back to the information like instruction before you can answer the questions. They said in the diagram below, 2 circles have a common tangent, TAB. So this is our tangent. And they said PT is a tangent to a small circle. And PAQ Q and N A R are the straight line, meaning that we have two straight lines that are cutting each other, so we have vertical opposite angles in between. That's what it means. And we have been given that Q is actually equals to 40 degrees. Now, the first question says, determine with reason 3 other angles that are equals to 40. So you have to try and pick up what is it that you can find being equals to 40. Let's take our colors. So we have this as 40. Remember, this is a tangent. And if this is a tangent, it means that the angle that is between a chord and the tangent, which is this, is going to be equal to the angle that is subtended by it. So the first question, which is question point 17.2.1, because this is from 17.2, we're going to say that also A2 is equals to 40 degrees, and the reason is the tangent chord theorem. Okay, that's our first information. What else can we say is that the angle Q is also equals to angle A2. That is because of the tangent and the chord theorem. Also, the angle 2 will be equals to angle A5. That is the vertical opposite angles. And this is a tangent, remember, to the small circle. So it means that A5 will also be equals to P2. That is the tan chord theorem to the other side. So that's what you're going to write down. And then they give you 6 marks. How simple that can be. So A2 is equals to 40 tan chord. And we said A5 is also equals to 40 vertical opposite angles. And also P2 in the small circle, it's going to be equals to 40 because the angle A5 is the one that is between the tangent and the chord. That is going to be equals to the P2. So this is another tangent and the chord theorem. Not to be confused is if you can label it properly, and then you get your 6 marks. Can you see how simple that can be? Nothing difficult. You see 6 marks, you get scared, and there's nothing you have done. You just have to remember your theorems. Look at a diagram that looks complicated, but it's not really. Try to uncomplicate it through the theorems, and then you are done. Okay. The last question says, if P1, so let's go to the diagram. If P1, this is what we are talking about, the whole of this angle. It's given to be equals to A4. Now, A4 is this angle there. So they are saying if this angle is equal to that angle there, what must we do? We have to prove that PTRN is a parallelogram. PTRN, it's a parallelogram. So we have to prove that this shape there is a parallelogram. Folks, what must we do? We must try to figure out her properties of parallelogram. And that's where we're going to get it right. Remember, if we have parallelogram, we have to have parallel lines. Opposite pairs are parallel, and also opposite pairs are equal. That is a parallelogram. Okay. One other thing is that if we have a line that is drawn on those parallel lines, so if we can prove that these two are P, T, and Rn are parallel to each other, then it means that those two angles will be equal in a way. So they're saying if P1 is equals to A4, then prove that PTRN is a parallelogram. Already they have given us one part which can direct to say TP is parallel to Rn. Let's write the information down so we can be able to deal with the situation. And you'll see how simple can this be if you are writing it. Okay. This information would say P1 equals A4. It was given, right? But this directs us to say PT is now parallel to Rn. Why? If we draw a Z there, look at it. Can you see? If we draw a Z there, we can find that these two are alternating. Because of these alternating angles, then we have these two to be parallel. So let's write that as our reason. So we have alternating angles. We are given them. Okay, alternating angles are given to be equal. That is the first thing. So what need to done now is that if we can prove that one other angle, it is actually equals to something else, or if we can prove that these sides are actually equal, or these sides are also equal, then we have proven the parallel lines, the other parallel lines, other pairs. Meaning if we can prove that TR is parallel to PN, then we are done. So let's see if we can do that. If I'm using TR as my parallel line, it means that somehow I need to figure out that my, let's move the T, going to R, we don't have a Z, we only have the F. Can you see that? We have the F there. It means that this angle there, which is R, it's going to be equal to that angle here. That is my corresponding angles from the given information. And also here, I will have my angles. Let's see which one and which one, because this is the line we're talking about. So it can be this. This is my line going there and going there. So this angle here is also equal to that angle here. They are alternating angles. So that's what we are looking for. So let's see if we can find that TR is parallel to PN, or alternatively, we know that PT is actually equals to TA. Why? Because they are the lines or the tangent drawn from the same point. They are equidistant. Okay, the line drawn from the same point, they are equidistant, which makes what is this, A3 be equals to P1. So A3 is equals to P1 as much as it is equals to P2, P4. So that is the information that we are talking about. If these two are equal, then that one will be equal to. So let's see if we can look at some other information that can lead us to what we are looking for. This is a triangle, and that's our exterior angle of a triangle. It includes that one, so it's not, because we talk exterior, we must go far. Let's see, this angle is also equal to that one there, and let me see, this one is also equal to this one there. What are we left with? So all the angles there are equal. We are done with that part. But if this is the case, then we have these two also corresponding. Okay, what we are looking for is to find this angle there. Let's label it a little bit. And this angle there with a relationship to talk about these two. Or we need to find this angle here and this angle here to have a relationship, so that we will have the corresponding angles, and that means these two will now be parallel to each other. So let's check. Looking at shape PTRA, we have realized that T is equal to R2 because PT is parallel to Rn from the given statement. Also, we have realized that this angle, let's see, this angle T, let me see if you can relate R2 with angle P, because that's what we need to get it right. If angle P is related to angle R2, so it means we have get to the solution. Let's see, angle P is equals to angle A4 as well. So it means, yes, that angle there, which is P1, is equals to P3, is equals to A4. They are all going to the same direction. Also, this is going to be equals to this one, because this is given. Let me write the information so that it doesn't confuse you. Angle P3, it's also equals to angle A4. That is the tangent and the chord on the small circle. So the tangent, the chord, and the small circle, it leads us to say that one is equal to this one there. Okay, and if that's the case, if this angle is equal to that angle there, and it's also equals to angle A1. Look at this one. If it's also equals to angle A1, it means now that our side TR will now be parallel to our side PN, because that's what we are looking for, right? Let's maybe write it somewhere there. Our aim is to find PN be parallel to TR by finding that angle T is equals to angle P3, and that will be the corresponding angles due to the fact that the two are parallel. So that's where we are going. So we say P3 is equals to A4. Now we said A4 is also equals to A1. Now A1, it is also equals to A1, which is this one. Okay, now A1 is equals to A4. So write it there, A1 and A4. And also A1 is equals to T1 plus T2. So the whole of T is also equals to A1. That is the exterior angle of this cyclic quadrilateral being equal to the opposite interior one. So that is the case. Let's write it that. We are saying A1 is equals to angle T. That is the exterior angle of a quadrilateral. Okay, if A1 is equals to angle T, and if T is equals to angle P4, that means that angle A1 is equals to P3. Okay, so let's put it here. A1 equals T, exterior angle of a cyclic, of a quadrilateral, okay, of a quad, and therefore A1 is also equals to P3. Okay, if A1 equals to P3, this is all because of this A1 is equals to A4, which is vertical opposite angle to each other, and then it is equals to P3. So if A1 is equals to P3, this is my A1 we are talking about, and we have said that A1 is also equals to T. So it means that both of them are equals to A1. So it means that T is equals to P3, and that makes PN be parallel to RN. So that is what we are concluding. This is what we wanted to do, so it's not really there. This is what we want to do. So we're going to continue. As long as these two are equal, it makes T to be equals to P3. Remember, this is because they are both equals A1. Okay, and if this is the case, therefore, TR is now parallel to PN. And that is because of we have corresponding angles that are equal. Okay, now this is the case. It means now we have two pairs that are parallel. Remember, the one was PT parallel to RN. Now we have TR parallel to PN. If we have two pairs that are parallel, it means that we have a parallelogram. So we are going to conclude by saying, therefore, PTRN is a parallelogram. Reason being, we have both pairs are parallel. So then you have answered that question. Usually it comes with 5 marks. It's a bit straining question, but if you practice it, you will get it right. And it's just all about knowing the basic of what it means of a parallelogram. So if you want to talk about a parallelogram or any other shape, you need to remember their properties and what makes them different from the others. Folks, this is the last question of the revision of geometry. I guess you're going to enjoy this, and you're going to make sure that you practice and practice and practice and make this geometry as simple as possible through your theorems and all those information that you have gained from your teachers and from all the information in internet and outside. And good luck with your matric. Thank you.